Okay, so that experience got me curious about houses and how they're built and how we could build them better. And it turns out that the University of Minnesota has a building science degree. And so that attracted me. So I decided to go to school and got this building science degree. And then I worked kind of in the industry after that, doing various things. I did weatherization for a few years. I worked for a home performance diagnostic testing company that also did a lot of insulation work. So I was figuring out why houses had problems and how to fix them. I was crawling through a ton of attics, digging through a lot of insulation, doing a lot of blower door testing and infrared cameras. How many of you, show of hands, I'm just curious, use an infrared camera with your inspections? Okay, here in the room, that's like probably about half, I would say. So that was a great experience. And then I ended up switching over into home inspections. And I did home inspections for about 7 years with a company based out of the Twin Cities called Structure Tech with Ruben Saltzman. And that was a great experience as well. And I learned a lot. I thought I knew a lot about houses before I became a home inspector, but I was extremely naive. And I realized the longer I'm in this field, the less I actually know. And I'm sure you guys have had that experience too, right? The older you get, you're like, wow, I really don't know anything. When I was 20, I thought I knew everything. Now wow, I was really naive. So I think all these experiences kind of helped me understand the house is a system. Everything from energy efficiency and comfort and durability to understanding just the basic, systems of the house, heating, cooling, plumbing, electrical, and how they all fit together. So that's kind of what this presentation is about today, is learning how to look at the house as a system. And now I actually do, consulting. I have a business called Your House Coach, and I work with homeowners and contractors and builders and help them solve problems and answer their questions. So that's fun. I actually just moved down to Tampa a year ago too. I'm from the I've been in the Twin Cities for the last 15 years, so I'm kind of getting my feet wet in a very different climate zone now and learning a lot more. So that's been fun. Oops, wrong direction. Here we go. Okay, here's just a quick agenda. I'm going to fly through this. Today, again, we're going to be talking about systems thinking about the house as a system. We're going to touch on just the fundamentals of building science, and that's all about heat, air, and moisture. We're going to talk about IAQ, indoor air quality. We're going to talk about comfort, durability, efficiency, and the challenges that go with that. And I'm going to dive into some real-world case studies too at the end. I've got about 4 case studies, and then kind of throughout the class, I've got a few more sprinkled in too. So I know that's where the fun stuff is. So I want to make sure we've got time to get to those, and then we'll finish up. Okay, so just starting off, for those of you who are not familiar with building science, I just wanted to kind of cover this base. What is it? So it explains how heat, air, and moisture move through a structure and how that impacts the durability, the efficiency, the comfort, and the health of the occupants. So it's really important, and it covers everything about how a house performs or how it doesn't perform. And that's really what I've found homeowners care about. They can't articulate this, but they all want to make sure that their house isn't making them sick, or it's not going to fall down, or that it's comfortable or efficient, right? So this is a quote from Joe Stebrick. How many of you have heard of Joe Stebrick before? Okay, a few people in the room. He's a pretty well-known building scientist, but he said, to create high-performing buildings, we must intentionally control these forces to prevent problems and ensure long-term success. So building science can and should be applied to both new homes, like this, and old homes, and everything in between. Again, just kind of zooming out, I like to think about the house as a system. All these interconnected dynamic parts, they all impact one another. So the occupants are one piece that impact the house. We've got the building and the structure itself, we've got the mechanical systems, and we've got the environment. And all these things are different variables and can lead to different outcomes. And so we have to think systemically about all these different parts and pieces, the best that we can to try and solve kind of these potential issues that could be going on with houses. So like I said, everything connects. We've got all these dynamic systems. You can make one small tweak in one area and it can have a domino effect in other areas. So it's understanding how these things kind of fit together. It's good to understand how the house is connected, thinking like a system, because I think that it helps you protect yourself when you're out there inspecting. If you can think about these things and understand your client and understand the house, you're actually reducing your liability too, because you're less likely to miss things that could be a problem for them. It's going to help you also stay competitive, I think, in an evolving industry. If you think this way, you're going to be ahead of the game, ahead of a lot of the inspectors that are out there. Now, there's the obvious, like this house, sometimes these issues they don't take a lot of digging. They present themselves easily. I'll play this little video here. Hopefully online you can see this too. This was actually taken by Ruben. If any of you have had a chance to attend his class on water intrusion, it's a great class. This is from that. But this is a brand new construction house. Brand new construction house. The people haven't even moved in yet. And you can see how the water's just pounding this wall, right? It doesn't matter, how they installed materials, if they did it 100% correctly, there's going to be an issue in this wall, right? And we can see that. That's obvious. But then there's the not so obvious sometimes, like this. Doesn't look great, right? So we want to try and find these issues for people. And we have to kind of put on our thinking caps sometimes and take a step back and put these pieces together. So this isn't about becoming a building scientist. It's about seeing the mechanisms behind the symptoms that you are already inspecting. So taking you from just being a box checker as you're walking through the house to actually being a risk assessor. Your clients will appreciate that. Being able to uncover hidden risks, not just the visible defects, and adapt to changing client expectations. Okay, I already said that. So one other thing I want to mention too, this is going to be a case study that we'll kind of look at a little bit later in, but this was a new construction house that was built in Minnesota, and they had some serious performance problems. And the homeowners were like, well, this is a new house. I don't understand. It was built to code. Why does it have these problems? And I've heard this time and time again too, even from inspectors on my own team. When I was inspecting up in Minnesota, someone built a custom home and they had comfort issues. They're like, well, the house is built to code. I don't know why I'm having these comfort issues. Well, you can build a house to code. It doesn't mean it's going to perform well. And so if a home inspector going through the house isn't identifying these issues, then who is for these homeowners and these clients? Okay. So I want to talk about how homes have changed over the years so that we can start thinking holistically, because it's really important to understand just the basic structure of the house when we're trying to figure out where the high risks and the liabilities are. You want to know how that house is built, what the materials are, the methods. And so houses have really changed, obviously, over the years, right? A house built in the 1800s versus a house built today, a super modern one. They're going to be very different and they're going to behave differently and they're going to have different sorts of issues, okay? So let's look at an example. If we've got an old house, let's just say quote unquote old, that could be, in my mind, anything like 1950 and prior. The Twin Cities has a lot of old housing stock, I would say, and that's kind of what I'm most familiar with. We've got houses from like the late 1800s all the way up until, just recently built. But we got a lot of houses that are, I'd say, 1920 and older. And so that's kind of what I'm talking about here when I say old. I'm curious, kind of what's the age housing stock that you guys deal with here on the East Coast? I know you probably have some really old structures too. Anybody want to shout it out? I can repeat it to the online listeners. Yeah, go ahead. Okay. 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 Okay, thank you. So there's stuff as old as the 1800s in some areas, but a lot of things from 1900, 1920s and on. So yeah, you guys have old housing stock here too. So one kind of just broad categorization, I would say, for quote older construction is that it's going to be not as well insulated, not very airtight. So it's going to be pretty leaky, lots of air exchange happening. And it'll probably be more drafty, less comfortable, less energy efficient on a whole. But because we have a lot of air leakage happening, we don't have a lot of insulation in the walls, those houses are going to be a lot more durable. If they get wet, they can dry out a little bit easier. And they're a little bit more simple to deal with. New houses today are, in general, going to be better insulated, more airtight. And because of that, they're a little bit more fragile too, right? If water gets in and leaks in around a window, we're probably going to have some issues. And I want to go through some of specifically these changes here. So as I mentioned before, the R values, the insulation levels have increased over the years. We also have materials that we're using in building assemblies that reduce the permeability, that reduce the amount of moisture that can kind of move through that wall assembly in that system. We use vapor barriers, we use vapor retarders versus a house built in 1900 that maybe had like tar paper. Now we've got, poly, things like that, or Tyvek, which does allow for vapor permeance, but still, just materials that reduce that moisture flow. We also have different types of materials in newer houses, right? And I don't know about you guys, but definitely like 1970s and on, in Minnesota, we see a change of kind of going from solid wood, like wall sheathing, wood planks, to using things like buffalo board or OSB. Buffalo board is like ground up wood pulp that's been pressed and glued together. We call it was wood. It was wood at some point, and now it's just some mash of, wood pulp. And so when OSB or like wood pulp gets wet, it doesn't last, right? It's gonna mold, it's gonna rot, it's gonna become structurally an issue a lot faster than wood that came from trees that were hundreds of years old, that were cut down and then used, solid lumber in a house. So just the materials will behave a lot differently in new houses. And again, newer houses are going to be tighter construction. So there's less air movement happening, less heat transferring through the structure to dry it out. So there's less drying potential because it's more airtight. And then we can have more complex air leakage. So this picture here on the bottom shows just the difference in kind of wood that we've been using in houses too. So this picture on the far left, you can see this darker color of the wood is actually kind of a naturally decay resistant part of that tree. And the rings are a lot closer together. That middle picture shows like new growth, new lumber, where we've got tree farms where the trees are growing really fast, they're cut down. We have the center parts where you can see where it's the darker color wood, that's called heartwood. It's a lot smaller section. We have a lot more sapwood, that's the lighter color, and that's not as naturally decay resistant, and it's softer. So we're using, again, different kinds of trees, different materials in these new houses, and you can see the difference in the studs too, from like a house built in 1918 to 2018. Look at how much more sapwood there is in the newer lumber compared to all the heartwood and the much more durable, older lumber there. So again, older homes were leaky, but they could dry out more easily because we have this transfer of heat and air moving through that wall assembly. So if water gets in, it can dry out. And also the materials are a lot more durable too. So if they get wet, they can withstand that moisture and they can dry and it'll be fine, right? So here's just some pictures of some older houses versus the new houses, which again are more fragile. We've got this was wood product. We've got the wall filled with insulation. We've got plastic over it, sealing it all in. So one little leak around a window could be catastrophic in like a 2020, stucco home versus a little leak around a window, maybe wood siding from 1900 that hasn't been insulated or air sealed. It's going to behave much differently. So that helps my frame of reference when I'm inspecting. Okay, is this an old house? Is this a new house? What's in the walls? How is it built? If water gets in here, is it going to be catastrophic or is it probably going to dry out? And again, it's not that new houses are worse than old houses. I'm kind of painting this picture. It's a little grim. I would say there's trade-offs, right? We can have an old house that's really durable, but it's not going to be comfortable for the occupants. It's going to be drafty, and it's not going to be energy efficient at all. So we've made our houses more energy efficient and more comfortable, which is what people want and expect. But because of that, we have to be really careful about all the details, the flashing details, the siding details, the design of the house, how we maintain it to make sure we don't have these catastrophic failures. And what gets really tricky is when we take an old house and try to make it newer. We add more insulation, we do air sealing, we replace the old wood with new wood, and how that, will then impact how heat and air and moisture move through the house. We reduce the heat transfer and airflow as well as, the material durability. So it's tricky when we take these old houses and we try to make them, quote, better or more modern, more efficient. We just have to be aware of that and those challenges. So one thing I want to mention, I hear a lot in the industry, people are like, oh, that house is too tight. That's why it's got moisture problems. And they think it's a bad thing that the house is airtight. Well, we actually want an airtight house. We want to be able to control how the air moves or doesn't move through the building envelope, because it can create all sorts of problems when we have air leaks, uncontrolled air leaks, moisture problems, durability problems, air quality problems. So we want to control that, and we do that by keeping the house tight. That's a good thing. But if we build a tight house, we have to provide some sort of ventilation for the occupants. So this is a building science kind of term you'll hear a lot. Build tight, ventilate right. Again, the myth is that houses need to breathe, but the truth is humans need fresh air. Houses need to dry out. Tight homes must have intentional ventilation for healthy indoor air quality. And for the house to not fail, if it gets wet, it has to be able to dry. So the drying has to be greater than the wetting for a new house. Okay, any questions about that stuff so far? That was just kind of big picture, how to think about a house and how houses have changed. Okay, we're gonna move on then to the fundamentals of building science. So there's three key players when it comes to understanding building science. And, building science can be a kind of an overwhelming topic, I think. There's so much to it. It can be very confusing. As I showed you before, there's lots of variables involved with, impacting how a house performs. But really, when it comes down to it, when you break it down to the core, it's really just heat, air, and moisture that will impact whether or not a house will fail or not. And so I just want to touch on how these things work, just the physics of them, so that we can apply that to a house and understand it better. So don't let this scare you, but this is thermodynamics, just really, really pared down here. This is not, I was not great in physics, I'll just say that, or chemistry, but we have to know it for building science. So somehow I managed to pass and get my degree, but this is what I've taken away from my years of college and being out in the field, is that energy is conserved. It can't be created or destroyed. And heat always flows from hot to cold, always. Reversing that takes energy, like if you've got an AC or heat pump or something like that. So again, the takeaway, heat always is moving, and it's our job to slow it down and control it. And we do that with insulation, air sealing, and HVAC. These are the ways that we control how heat moves in and out of a house and through a house. So diving into heat a little bit more, again, it moves from more to less energy, always. So heat moves from hot to cold. There will be a quiz on this at the end, you guys. I hope you're paying attention. Okay, and then also the difference in temperature will impact how much heat gets transferred. So the greater the difference, like let's say it's really, really cold outside, warm in your house, that's going to drive more heat transfer, okay? Now there's 3 different modes of heat transfer. We've got conduction, convection, and radiation. Conduction happens through solids, like through wood framing in the wall. We can have things like thermal bridging, like this. Here's an infrared picture overlay of looking at a vaulted ceiling, and you can see there's the purple is cold spots there. So this is actually, there's an attic on the other side of this wall, and that the fiberglass backs between the studs had fallen down, so there was just no insulation on the back side of this wall. So you can see how cold that is, but you can also see how the studs are warm, right? So it's warm in the house, cold in the attic, the studs are warm, we're losing heat through the studs, through conduction. That's why we insulate, is to slow that heat transfer down through conduction. As I mentioned before, you know, that framing has a lower R value than the insulation between it. So here's a picture of a roof that was spray foamed. And this was actually, this is actually Ruben Saltzman's house, I believe, in Minneapolis. This was a 1.5-story home he owned for a while. And those homes are notorious for ice dams. Do you guys have 1.5-story homes here? Okay, yes, and I'm sure you guys have ice dams occasionally too, right? So is that, okay, you guys are aware of those issues. But anyways, he thought this would fix the problem. Let's just add a bunch of spray foam, high R value, to the roof deck. And turns out he still had enough heat loss through all the rafters that it still melted the snow on the roof, and he still got ice dams. So we have to think about this and thermal bridging and all the heat loss that can happen through that. Here's another example, again, kind of a slant ceiling. You can just see it's cold outside here. We've got some insulation between the rafters, so the rafters are a lot colder. We're losing a lot of heat through them. And have you guys ever seen anything like this before? Yes, okay, I'm seeing a lot of heads nod. So I call this ghosting, but this is just indicative, again, of, this is a visual representation of how cold, you know, these spots can get when it's cold outside. We've got all the heat transferring through the wood framing in the wall. The surface temperature, right where the studs are, is gonna be colder than the bays around it that are insulated. And so if you have someone who's a smoker, or they like to burn their candles a lot, sometimes you'll see this soot stick to those cold spots, and we call it ghosting. Okay, so that's thermal bridging and conductive heat loss. We also have convection. That's how another way heat can be transferred. We've got something called stack effect, which I'm going to give you another slide here coming up that gives you some more visuals of this. But bottom line is the warm air is less dense than cold air. So the cold air will sink, and that pushes up the warm air. The warm air is going to rise. And if we have leaks in the top of the house, in the attic plane, let's say, that warm air is actually going to push up through those leaks. And so we end up with a positive pressure at the top of the house. And for every CFM of air that leaks out, another CFM of air gets pulled in lower in the house where it's a negative pressure to replace it, because the house is not a vacuum. So if air's leaking out the top, air's being pulled in at the bottom. So we get a positive pressure at the top, negative pressure at the bottom. So how many of you have like been in an older house that's pretty leaky? In the wintertime, it'll be a lot hotter upstairs and a lot colder downstairs, or colder in the basement. Okay, that is, you're feeling this, you're feeling stack effect happening. And I've seen this too, where, I'm gonna go to the next slide because I've got some more, animations here. Here's an example. On the left, we've got winter where it's cold outside and warm in the building, so that warm air is rising. And it's leaking out through the top where it's a positive pressure. And this is, you know, just saying, if you're measuring these things, there's lots of tools and industries that can measure actually what pressure it is at the top and what pressure is at the bottom. But just for example's sake, we'll say it's positive 12 pascals at the top, negative 12 at the bottom. That gradient for the pressures, you know, increases as we go up. And then somewhere in the middle, where it switches from a negative pressure to a positive pressure, we have neutral pressure in the building, where air isn't leaking out or coming in, where it switches. So just depending on how tall the building is, and how many leaks we have, where they're located, that neutral pressure plane can change. But where I've seen it be interesting is like in Minnesota when it gets really, really cold outside. If you've got, my parents live in an apartment building, a really old apartment building that was redone recently, and they're on the top floor. Their windows have frost on them. It gets stuck between the pane and the storm, and the first floor doesn't. You understand why? Because that warm, humid air is rising and pushing out. And so then that moisture is getting trapped between the storm and the window and condensing and freezing on that cold storm. The people on the first floor, they've got a negative pressure. They complain about their windows being drafty and leaky. They feel the cold air coming in, it's being sucked in. So my parents on the top floor, it's being pushed out. Their windows feel comfortable but get frosty. The people on the first floor don't have frosty windows but think that their windows are leaking. So a lot of times people think the windows are the problem in the house and they want to replace all their windows. But a lot of times you can have a much greater impact for lower cost if you air seal the lid of the house. You stop that air from leaking out. If you reduce the amount of CFM that's leaking out the top, you're going to reduce the amount of CFM that's being pulled in lower in the house to replace it. And it's going to make the house a lot more comfortable if you do that. And then just quickly, we'll reverse this and I'll show you. In the summertime, it's the opposite. Okay, so we've got, for air conditioning inside, it's hot outside, it's cold inside. Remember, heat goes from warm to cold, more to less. We're actually pulling in that hot air. If we're air conditioning, that cold air sinks. So we get a negative pressure at the top, positive pressure at the bottom. We're actually pushing air-conditioned air out at the bottom. We're pulling in hot, humid air at the top. Now, this is an interesting picture too. I took this when I was inspecting a high-rise condo, and I went outside to test the receptacle, and I couldn't get the cover open, and it turns out it was frozen. So this is at the top of a very tall building on an exterior wall. You can see how much moisture is in this outlet. So all that warm, humid air from inside, that conditioned air, leaked up through the exterior wall and was pushing out, right, through that outlet and froze it up. Okay, so that was convection. We did conduction, convection, and then radiation is the last piece here. We can have heat transfer through things like solar heat gain, sun coming in through windows, or sun warming up a structure. Passive solar heat. Here's an example. In the south, this is a habitat build I was working on. They use something like this on the roof deck. It's an OSB that has like a reflective barrier built into it on the underside to help reflect back out the heat from the sun, which is kind of cool, I think. Well, hopefully it's cool. Hopefully it keeps the attic a little bit cooler. Okay, that's heat. Let's move on to air. So the basics of how air moves, mechanics. If you have airflow, it means you have a pathway, like a hole, and you have a pressure difference. You need both for air to move. And the pressure difference could be caused by a few different things: a change in temperature, wind, or mechanicals. And the rate of that airflow is going to be a function of the hole size and the pressure difference, right? So the bigger the hole, the bigger the pressure difference, the more air you're going to have moving, right? Here's just a visual example of, what causes these pressure differences. Again, if you've got wind pushing on the building, that's going to create a pressure difference. Also, we talked about stack effect. That creates different pressures in the house, and mechanicals, fans. If you've got a furnace and maybe you've got ductwork in an attic, potentially it's leaking, that can create all sorts of pressure challenges in a house. So a lot of times you've got all these different variables kind of happening in one house. So it can be challenging to kind of figure out what's happening. Visually, I'd say as a home inspector, look for the clues. And I'll go through a lot of examples in my case studies. But houses are really good about telling you what's wrong. You just have to pay attention. You have to be thinking and looking for these symptoms of problems. As I mentioned before, this is just a kind of a picture from DOE's website or the EPA's website that shows kind of common air leakage locations in a standard house. And this is, again, if it's, cold outside, warm inside, that warm air is rising, it's leaking through all these little cracks and leaks. We've got ductwork in the attic in this house, so we've got lots of penetrations in the ceiling where that air is leaking out. One thing it doesn't really show well is we're gonna probably have a lot of duct leakage as well. So we're gonna have warm air when that furnace kicks on, leaking out through the ductwork and outside of the furnace too, where the fan and blower are, which is creates all sorts of comfort issues, energy efficient issues, maybe ice dams, things like that. And then where it's a negative pressure in the basement, we're pulling in cooler, drier air. Okay, move on to moisture here. We've got moisture, as we all know, as home inspectors. This is kind of the number one concern for a lot of people, right? Because it can cause structural issues. It can create mold and air quality concerns. So everybody's aware of that. All the, home buyers are, scared of those things. And so we really want to make sure that we're able to manage moisture in a house so that we can manage that risk. Moisture always flows from more to less, okay, from wet to dry. And it's going to go from warm to cold, more to less energy. How many of you have heard of a psychrometric chart before? Okay. Oh, you get an A+, Sean. All right. So this looks scary, but really it's just a visual representation of how when you have warmer air, it can hold more moisture. And at some point, when that warm air gets cooled down, the moisture will condense if it hits a cold surface. So this chart will tell you on the bottom, let's see, I'm going to click this. Okay, let's just use this for example. We've got along the bottom, the x-axis, it's really tiny, hard to see, so I'll just explain it. This is the dry bulb temperature, and dry bulb temperature is like the temperature in the room. So let's just say I've got 70 degrees circled here. Okay, I'm just going to draw a vertical line so we can see where that 70-degree mark is on this chart. Okay, now let's pick a relative humidity, let's just say in a standard home. We've got about 50% relative humidity. Let's hope that this is not like dead of winter. That's pretty high, right? Maybe this is summertime. Maybe not, don't know. Do they use a whole house humidifier? Do they crank it up? So if we've got this, we've got 50% relative humidity. I'm gonna try and show this. Okay, so these arcs here are representing relative humidity. So we'll take that 50% line and run it down until it intersects with our dry bulb temperature. Okay, once it hits that dry bulb temperature, we shoot over to the left. And then this line right here is our wet bulb saturation temperature. Basically, that just means dew point. Okay, so this is gonna tell us at what temperature we'll hit the dew point and we'll have condensation. So on this chart, that's about 50, oops, let me go back. It's about 52 degrees. So the higher the relative humidity, the warmer temperature we'll get for a dew point, if that makes sense. Okay, so this is a pretty neat tool. And if you've ever been in a house where, maybe they've got a closet like on an exterior wall, and they've got a lot of things stored in there up against that wall, it's a great place to look for mold because a lot of times we don't have as much heat and airflow getting to that corner because they've blocked it with things and it's isolated from the rest of the house. They've got a door shut. There's no supply register, anything like that. That surface temperature of that wall is going to be a lot cooler than the rest of the house. But we still have, regular humidity, indoor humidity in this house. And so when that warm, humid air touches that cold surface, we're going to get condensation. And condensation is when you can get mold. All mold needs to grow is moisture and a food source, like a piece of dust, and you'll get mold. So the key is, okay, what can we do? We can either increase the temperature or we can decrease the relative humidity to change that dew point. Right? So the easy solution is, okay, just don't store things in this closet and keep the door cracked. So we can, move things away from the wall and keep the door open so we get more heat and more airflow back there. So we don't have a higher likelihood of condensation from forming. Okay. Any questions on that? Now you don't have, okay, if you want to really impress clients, you could carry this around and show them this, but they make apps for this these days. Yeah, or yes, like they do make apps for this. So you could put this on your phone and you could just literally, you can plug in what the temperature is in the house. And if you carry around, a humidistat or another tool that tells you the humidity, you can plug that in too. And you can see what temperature you would get a dew point at. And you can play around with that. And you can show the homeowner that too. So they understand, okay, well, if you're dealing with condensation and moisture issues, well, look at, you need to decrease your humidity. And here's what, relative humidity you need so you don't have problems at this temperature. And in general, the colder it gets outside, the lower the humidity needs to be in the house, right? So you don't have these issues. So how does moisture move? Okay, in a few different ways. We've got bulk water, which would be like rain coming in or snow. We've got capillary action, which I'll show you some examples of that. Air can move moisture, and vapor diffusion can happen too as well. So I'll go through some examples. We're going to start with bulk water because this is usually the source for the biggest, ugliest problems in houses. When we have bulk water leaking in, we can have structural damage, mold, durability problems. So this is roof, wall, foundation leaks, and this is where exterior water management is critical. So here's just an example. We've got this was an old, like 1920s house in Minneapolis. It was beautiful, but had been neglected for a while. And you can see on the top right, let's see if I can get my little laser here. Whoop. Okay, there's a little tiny piece of flashing there, but it didn't used to be there. So it had had years and years of water just running down this roof and running down the wall, and you can see the brick at the bottom there and kind of hitting that area. Now, the client who bought this house was doing some major renovations, so they gutted it, which was kind of cool because then you can actually see the effects of, water leaking in over years and years and years. And this is an old house too. Remember we talked about how durable old wood was? Well, when it's had decades of water getting in, it'll rot too. So we want to really be conscientious of thinking about where water is getting in. Here's another example. Now this house is newer, it's the 1980s, but we also have this really kind of funky roof line, that long stretch of roof where all that water is being funneled right down into the wall next to the window, right? Great design, great design. There's no flashing there. So right away, again, spidey senses, when you're inspecting, you're thinking about, okay, where does all this water go, right? And we want to make sure water's not getting into the house. This is high level. This is the area I focus on the most. It matters the most. Bulk water, okay. This would be an area of concern for me looking at this. And interestingly enough, it actually shows up with the infrared camera. A lot of times you can't see moisture in the wall with an infrared camera from the inside because it hasn't reached the sheetrock yet. It has to go all the way through the wall sheathing. If you have a vapor barrier, I don't know if you guys do, if you guys have vapor barriers in here. But for us in Minnesota, it would be, wall sheathing, insulation, vapor barrier, drywall. It would have to go all the way through that to get the drywall wet for you to typically see it with the infrared camera. A lot of times you can't. But this house, it had been so saturated for so long that it was. And I pulled the carpet back and you can just see the mushy subfloor right there. So this bulk water is devastating to houses. We really need to pay attention to that. Next on the list, we've got capillary action. And this is where water can wick through porous materials. So for instance, concrete. I know you guys have basements here, right? So a common thing that you might see is efflorescence. And I'll show you a picture on the next slide of what that looks like if we're not aware of that. But we can stop that or reduce that moisture migration through a porous material by doing a few different things. We can put in a capillary break, which a lot of old construction probably won't have that, but they do that in newer construction houses. But every house, we need to be conscientious of better water management, as we all are. We're thinking as we're walking around the house, we're inspecting it, thinking about, where is the water going? What are the roof lines doing? Do we have gutters? Do we have proper downspouts and extensions? What's the grading look like? And so here's an example of efflorescence where we've got moisture that, again, moisture goes from more to less, wet to dry. So if we've got wet soil in contact with porous concrete, which way does that moisture want to go? Yeah, it wants to come from the wet soil into the house where it's drier. So that moisture migrates through the concrete, and when it evaporates, it leaves behind the salts from the concrete, which creates that kind of fuzzy white look. And a lot of times people will paint over it. And so then it just gets kind of rough looking. And if you push it with your finger, you can usually break through the paint bubble and it'll be kind of chalky in there. So that is just a natural thing that happens when you have moisture moving through concrete. One thing I hate to see is when people decide that they're going to finish their old basement and they put some sort of insulation and vapor retarder right over that porous concrete without addressing any sort of water management issues on the outside. And then they're shocked when they have mold later. Right? Well, what do you expect? You're playing against nature's law of physics here. When you trap that moisture in the wall, it's going to come through the wall. So unless you have a newer house that has excellent waterproofing on the exterior, and we've got great drainage, great gutters, great grading, capillary breaks in the slab, I'm very cautious of finished basements because of just how moisture moves through them and the potential for mold. Capillary action can happen too if we've got something like stucco or stone veneer, adhered masonry veneer, which you guys have a lot of that here. Yes, I'm seeing some heads nod. So if it's not installed properly, if we don't have, gaps between the bottom of the stone veneer wall and the grading, if that stone veneer goes into the dirt, again, it's porous, and so that moisture will wick up through the wall and create issues. Here's a perfect example. This was a house in Minnesota I was inspecting that just over the years, they had kind of kept adding landscaping layer after layer after layer around it. And it didn't have a full basement. Some parts of this house had a crawl space and some of it didn't. It was pretty weird. But on the inside, they started doing some demo and they found that their rim joist was gone. That moisture had been going through that wall long enough that it had rotted out that rim joist. And so they were trying to figure out how to fix that issue. And really, I mean, a great solution would be to dig out that wall so it's not below grade anymore. But devastating effects of just capillary action happening. Here's a house in Florida where sadly, these homeowners had put down this nice kind of like vinyl, flooring material, would look, and it had only been down for a few years, and it started warping, and so they ended up pulling up a few pieces, and there was just tons of moisture on the backside. And they're like, we don't understand because the house hasn't flooded recently. We haven't had a hurricane in the last few years, and they didn't know where this moisture came from. But we've got a slab on grade. And so, this is an older house. We don't have any sort of, I don't think, great capillary break underneath the slab. Even though it's very sandy soil, we're still going to have moisture that wicks up through the concrete, wants to dry to the inside, and it gets trapped between the concrete and that vapor barrier vinyl flooring on top, and we get this moisture buildup. That's why a lot of, flooring manufacturers require some sort of vapor barrier underneath the material so that that moisture that's coming up doesn't actually get to the flooring. It's going to get trapped on the backside of that vapor barrier between the concrete and the vapor barrier. Okay, another way that moisture moves is through air transport. So let me show you some examples of this. Cold climate. Remember, we talked about stack effect and how warm air will leak up through these leaks in the attic lid. So if we have warm, humid air coming into a cold space and it hits a cold roof deck, remember the psychrometric chart, it's a really cold surface, warm, humid air, it's going to condense. And if we get a long stretch of really cold, then we'll get a thicker layer of frost, right? So this was a newer construction house that was just covered in frost. And if it's not wintertime, you can still look for signs of this issue in the attic. A lot of times you'll see dark staining, or you might see rusty nail tips. This is an extreme one here. But you know, you'll typically sometimes you can use just the dark staining as a roadmap for maybe where they've got air leakage happening as well. And then last one, vapor diffusion. This is how moisture moves through walls. And so we use things like vapor barriers or vapor retarders to try and slow that down. And the location of those depends on what climate zone you're in to where we put that vapor barrier. I'll go through this quickly, but here's an example. This is a drawing from Building Science Corporation. This is a Joe Seabrick company. But anyways, we've got a cross section of a wall here, and we've got a brick veneer on the exterior. We've got a little air gap, and then we've got, you know, the wall cavity that has fiberglass insulation in it. So if it's 80 degrees outside and it's 75 degrees inside, we're cooling. Which way does that typically the heat want to go? From warm to cold, you know, from out to in. But if we've got the sun beating down on that wall, and let's just say it had been raining, so that wall was saturated, well, it's heating up that wall. So actually the temperature inside that wall cavity is 100 degrees from the sun beating down on it. And so if we've got a saturated brick and we've got 100 degrees in the wall and it's cooler on the inside on the other side of that, we've got kind of an interesting situation happening here where that brick wants to dry both to the outside and to the inside. And that differential in vapor pressure is driving that moisture through the wall. So it's drying to the outside, but it's also driving it through the wall. So I'll see in situations, even in a cold climate where we've got a vapor barrier behind the drywall, where moisture has kind of been pushed through the wall sheathing, through the insulation, and it's gotten trapped behind the vapor barrier. So here's an example of that. We've got adhered stone veneer on this section of wall. It's a walkout. They hadn't finished it yet, and they could not figure out why they were getting all this moisture and mold growing behind the poly. Another factor that can happen a lot of times though too on these wall assemblies is if you have any type of little hole in that poly or that plastic, which most of the time there is, right? Let's be real, how many times do you see a perfectly installed vapor barrier? When it's cold outside, warm inside, that warm humid air is pushing out, we'll get moisture trapped behind that poly just from air leaks too. So this is a tricky wall assembly. Depending on what's going on, we can have moisture being driven inward because of the stone veneer holding that moisture and a sun beating down on the wall. We can also have moisture being driven through the wall from the inside when it's cold outside and we've got air leakage happening. So we've got different methods of moisture transport happening in the same wall, and that moisture is getting back there for a few different reasons. Here's another example, vinyl wallpaper on the inside of a wall. If you're in a hot, humid climate, don't do it. This is from a paper from Joe Seabrick, top 10 dumb things to do in the South. Okay, I see a question. Yes, sir.
Back there on that, in that basement, one more back.
Yeah.
Where you've got that poly, what's the answer to that? Where do you put the vapor barrier?
That's a great question. So I don't have that figured out because if you've got something like stone veneer and it gets wet, that vapor drive is going to be pushing inward. And if you have a vapor barrier that doesn't allow has zero permeance, that moisture has nowhere to go. It has to dry back out the other way through the outside again. So that's pretty tricky. I think the way to go is like a smart vapor barrier, something that allows a little bit of drying potentially on a wall assembly like this. Or you could do something like a closed-cell spray foam right directly to that wall sheathing so the moisture can't get trapped behind the poly in that situation. But most of the time, if you don't have like a, you know, stone veneer that's holding a lot of moisture, you don't have a sun beating down, or you've got good overhangs that are protecting that wall from getting wet, then a lot of times this moisture is in there because of the air transport, the holes in the poly that's allowing the interior warm humid air to get back there and trap it. So usually the fix is, you know, install a better air barrier there so that we don't get that air leakage happening that's bringing moisture in the wall. It's tricky though. It's very tricky. This is why a lot of basements smell musty because of stuff like that. Yeah. Good question. Okay. Last thing on vapor diffusion here versus air transport. This is just this came from a study from Building Science Corps. And this was looking at I think a house in Chicago, a colder, drier climate, where they did an experiment and they wanted to see how much moisture moved through a 1 inch by 1 inch hole in a 4x8 piece of sheetrock over the course of a heating season. So it was like 70 degrees inside, 40% relative humidity. They cut this 1 inch hole to see how much moisture leaked through this hole. And they got 30 quarts of water in the wall just over the course of one winter from that 1 inch hole. Most people have, 70 degrees, 40% relative humidity. That's a ton of moisture that can get into the wall, right? That's kind of scary. You're loading up that wall with tons of water from that tiny little hole, right, through air leakage. And you can still get moisture in the wall through something like vapor diffusion. You can see the picture on the left. Diffusion is where that moisture is kind of just migrating through that material organically, but it's much, much less, right? So that's why we use vapor barriers in a wall assembly, is to stop vapor diffusion. But really, you can see where we should be focused is on the holes and sealing those up, because that can be devastating for a wall or for an attic. Yes, we've got another question over here. There we go.
So are you familiar with the products like Aero Barrier? And do you how do you feel about those type of products for this type of situation?
Yeah. Yeah. The question was about aero barrier. So I'm seeing that. I think that's it's becoming more prevalent, using something like aero barrier, something that can seal all these little holes up, and definitely in commercial settings. Yes. I think we have to be careful because some builders that don't know how to really build a high quality airtight structure are just relying heavily on something like aero barrier to just fix all the problems. So I think we just, ideally as an industry, we learn, how to build something well. And then maybe we do use something like that to fix these little cracks and holes that are really tough to get. It's an option, and seeing it more in commercial buildings where they're using stuff like that to seal. A lot of times in most houses, you can do a pretty good job air sealing at the time of construction, or potentially during a retrofit you can go in. Now there are some designs where that's tough to do, where maybe that is a good solution. But ideally I'd say you don't need to go all the way to aero barrier. You can actually kind of pull the insulation back and do some physical air sealing to seal up these big holes and make a good enough impact. Good question. Did I answer your question? Okay, cool. So I just want to show you a real world example here, quick, of how moisture can be transported through things like air leaks. So this was a house in Minnesota, and it was built in 2017. This was an old inspection I did a long time ago. So it was new, quote unquote, and it was built to code and passed all the city inspections. But the homeowner contacted us because they discovered water dripping in from the ceiling and down the exterior wall in January after they'd moved in. And this issue did not occur the previous winter. Again, this house was new, so the homeowner was just overwhelmed and like, why is my house leaking water? And it was in, the dead of winter too. We hadn't had any rain. So the goal was to figure out why this moisture was happening, where it was coming from. Some additional data points here too. The water was noticed after several days of sub-zero temps. So that's important. Also, this house, they kept the original foundation, but then they basically rebuilt the whole thing up from the foundation. So 1950s foundation, all new construction above that. And the builder was very proud of the fact that he had used closed-cell spray foam in the exterior walls. That was, above the requirements. And so he was kind of, very proud of that fact. And there was 16 inches of blown fiberglass in the attic. Anybody have any kind of thoughts on what might be causing this moisture issue? Do you want to use the mic real quick? Thank you. I'm just trying to be a rule enforcer here, sorry.
Spray foam must be trapping the insulation, not allowing the wall to dry.
Okay, the spray foam could be trapping the moisture in there and not allowing it to dry. That is a really good assumption. Yep, okay. I'm going to go through some pictures with you guys here, and maybe this will help kind of paint what's going on. It'll tell the story, okay? So walking around the outside, doing a visual kind of investigation of this house first. I notice on the north side, we've got drip marks coming down through the soffits, down the exterior wall, like underneath this overhang. So it's not drip marks from rain. It's drip marks coming from somewhere above this, right? And then we also have on the inside, it's kind of tough to see, but on this exterior wall, this is the same north wall, there's drip marks below the window, and then there's also drip marks around the chandelier hanging in that stairway right in front of that window. So water's been kind of leaking around that light as well. And then this is also looking at that north wall. We've got the owner's suite bathroom, and you can see we've got a shower kind of on the exterior wall, and we've got lots of can lights in this bathroom. Here's the bedroom. Again, we've got a common theme here. Lots of can lights. Here's my own shot, and it's not very good, but you can kind of see if you look closely. Ooh, okay, see the stains on the ceiling? I'm really stretching here. Hard to see, but there's lots of water stains kind of at the drywall seams on the ceiling in the bathroom area. Tons of moisture. More can lights, again, more can lights. This builder really liked their can lights. Okay, let's do a look in the attic here. So it was so wet up there that someone had installed fans to try and dry it out. And now you can see construction of this, it's a scissor truss. So it was vaulted ceilings in the house. And in the attic space, you could crawl kind of along the peak down the trusses. But at the exterior wall tops, the heels pinched down and got really, really narrow. So it was tough to get down to the exterior wall tops, to the eaves. Now, some people would say, okay, you know, this attic has moisture issues because it's not vented properly. We need to add more ventilation. Okay, well, let's rule that one out. We've got good vented soffits along the entire exterior of this home, and we've got vent chutes that have been properly installed. You can see daylight, and we have a continuous ridge vent installed. So, I mean, venting is probably not the culprit here. What about bath fans that could be disconnected and blowing warm, humid air into the attic and creating all these moisture problems? What about that? So going through the house, there was like 3 bath fans along that north wall, making sure they're all accounted for. Okay, so we've got one. It's attached, venting out, no dark staining around it. Seems to be working okay. Oops, bath fan number 2. We can see at the eave there, maybe there was only 2, I can't remember. Okay, now let's do a little bit more digging. This is the base of the bath fan. This is the actual fan housing itself. Do we see any problems here? Yeah. Okay, I see lots of head nods. Yes. What's the problem? Someone, you just shouted out. Yeah, it has not been air sealed. We've got gaps around this fan housing and the sheetrock, right? And using the infrared camera, we can see a lot of heat loss happening here. Warm air from the house is rising and leaking around this fan housing into the attic. Okay. Now this was a fan that was accessible kind of from the peak. So I could just kind of reach over, pull the insulation back and take a look at it. Okay. Here's another penetration that was easily accessible. Plumbing vent going through wall top. Okay. Remember all those can lights we had? Let's take a look at that. Not sealed at all. Now take that times 50. Remember that drawing of the sheetrock with the 1 inch by 1 inch hole on it and how much moisture you'll get going through that little hole? Now take that times like 100, right? Now this house passed all the city inspections. It even had a blower door test, and it had to be 3 ACH 50, 3 air changes per hour or less. That's what Minnesota code is. And it passed that. This house was pretty airtight. Remember, the builder used spray foam in the exterior walls. So the walls are extremely tight, but the lid is pretty leaky. It still meets the air tightness requirements. It's still a pretty airtight house. But because we have all these air leaks happening in the lid, and we've got bathrooms, places of high moisture creation, located kind of, right along an exterior wall top where we've got, the attic has less volume at those eaves. It's smaller. The actual space between the ceiling, I'll get to in a second, between the ceiling and the roof deck is smaller. And we've got can lights right along there, and we've got a shower right below that. We're literally creating a ton of moisture, injecting it through a little hole, and then it's condensing on the backside of that roof decking, right? Okay, question back there. Yes, sir.
In the crawl space. So you said
Great
50's foundation.
Yeah.
You got to wonder about moisture that's permeating and.
Yeah, great
and
question.
envelope.
Great. I like how you're thinking. Big picture here, right? Okay. You read my mind. Let's go downstairs. So it's actually a full basement. We had concrete block walls, and it was actually pretty dry down there. But one piece that was playing into this was we have a fresh air duct bringing fresh air directly from the outside, and it's ducted right into the return of this furnace. Okay, so it's pressurizing the house. So because we've got this mechanical kind of setup, and we don't have balanced ventilation in this house, there's no HRV or ERV at this time. The builder is right on the cusp of needing to put that in for code requirements, so he got away with not doing the balanced ventilation. He installed one of these instead. It created even more positive pressure at the lid with all these penetrations. So it's kind of like the perfect storm happening in this house here. And also, the homeowner had wood floors and wood trim that he was really concerned about in the wintertime, didn't want it shrinking and cracking. So he also had a whole house humidifier installed and had been keeping that nice and humid in the winter. So we got all these different mechanical things contributing to the pressures and the air leakage that was happening. Okay. Yes, sir.
Did you call it the polybutylene?
Oh, yeah, actually, that was not the subject of this inspection. And this was 2017, so I don't think this was PB, but it looks like it. Yeah, yeah. Never had anybody point that out before. Sharp. Okay, so just quick review. The building science, putting all the pieces together here. We've got closed cell spray foam in the exterior walls, so making them airtight. We also have these unsealed attic bypasses in the lid. We've got the location of where they're at. Again, on the north side too, which that slope of the roof sees less sun. So when we've got lots of sub-zero weather, that roof deck temperature is never getting above freezing. So that layer of frost is just building, 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 right? And the first warm day we get, that frost is going to melt and it's going to drip. When it drips down through the insulation, hits the back of the poly on the back side of that attic floor, it'll run down and find the first seam or the first cut that it can find, right? That's why we were seeing water dripping through the light fixture base and water along the seams of the sheetrock, because it's literally just running down that poly, and also can run down the roof deck. And when it gets to that exterior wall, what's going to happen? It's going to run down the exterior wall. And thanks to the builder, we have a nice closed cell spray foam in the wall, which has zero capacity to hold any moisture. Like if it was dense packed cellulose or something, we may not have seen the water dripping out of the windows on the first floor. But because we had closed cell spray foam, that water was just boom, running all the way down and coming out the first opening it could find the windows on the first floor. And then again, weather conditions will impact all of this, right? Like, so the sub-zero temperatures and which way the house is facing. And then again, lack of balanced ventilation. Instead, we've got positive pressure happening in this house. So all of these things, all these factors and variables are creating potential air quality issues because we don't have ventilation. We've got moisture problems. We can have mold problems. We could have rot issues, durability, performance. So it's a mess. Okay, so again, the frost was accumulating in the attic due to these attic bypasses. and was exacerbated by indoor humidity and the attic design and the mechanical pressures. And that frost melts in warmer temps and drips on the attic floor and into exterior walls. And people are so confused because like, this house passed all the inspections. Why is it? Well, just because it passed inspections doesn't mean it's going to perform well. We have to understand building science and what's going on. Okay, so this was a house that had closed-cell spray foam installed, a hot roof situation, and you can see there's a few bays where we've got melted frost. So we've got, somehow that roof deck is warmer than the roof deck around it that's still frosty. So this was a blower door test with an infrared camera. The black is cold. You can see there's air leakage happening still somehow. Even if you've got spray foam installed, if it's not installed perfectly, or even if they did a good job with the spray foam, if they haven't caulked even between the rafters where the wood meets the wood, or if they put in a new light, we can have air leakage and air movement. And remember, to have air leakage, what do we need? We need a hole and we need a pressure difference, and you'll get air leakage. And when it's really cold outside and warm inside, or vice versa, we'll have that air movement happening. And here's another example. Cathedral ceiling, there's some sort of air leakage happening in that bay somewhere lower down, and we can see dark staining on the underside of the roof deck right in that bay. So we know that moisture is getting into that bay and transferring up somehow. Now, that leak ideally needs to be sealed because otherwise it's just going to rot out the roof deck over time. Or if we can't seal it, we need to be really cautious with our humidity levels inside the house too. Okay, so we've got IAQ. I'm going to kind of go through this one quickly. We're all kind of aware of the bad stuff, quote unquote, that we find in homes that create health issues for clients. But mold is a huge one. Then we've got all these other factors like dust, pet, dander, pollen. And then we can have pest droppings. And especially nowadays, I think people are really aware and talking more about like VOCs and fine particulates. And then, you know, as home inspectors, hopefully we're looking out for carbon monoxide, potential carbon monoxide issues, and educating people about radon too. But there's lots of things that can make a house sick, make people sick. So mold, again, it's a symptom of a bigger moisture problem. And so the way I like to think about it is instead of just rushing to, oh, there's mold, or, you know, I don't know about you guys, we were never saying it's mold because we're just inspectors, but, you know, mold-like substance or something until it gets tested and verified. But I wasn't rushing to pushing people onto doing tests to find out if it's mold or not. For me, I'm more curious, okay, why is this here? How did it show up? Is this, you know, what's causing it? Do we have leaks where bulk water is coming in? Do we have air leakage where moisture is moving out and getting trapped and condensing? Do we have, you know, vapor diffusion problems? Do we have a high humidity issue in the house? Where is that humidity coming from? Are they using a whole house humidifier? Do they have working bath fans? Are they using them? What's creating this moisture problem? And how do we fix it? Because to me, if I was buying a house, that's what I want to know, not what species of mold it is. I want to know why is it there and what do I do to fix it and get rid of it. So I think as a home inspector, again, this is going beyond what our standards of practice, you know, call for us to do. But I think, you know, being a detective and a problem solver is very valuable for the clients, and also, you know, for liability reasons, to try and catch these things and understand what's happening. So moisture and humidity problems, again, if we've got poor dehumidification, you know, signs and symptoms to look for these issues. This is really bad, but condensation on windows, too much humidity in the house when we see this. And a lot of times too, people will maybe have like heavy drapes, blackout blinds, you know, covering windows, and you know, then they open them once in a while and they realize there's all this mold growing behind them and they're freaking out. It's, you know, their window has failed. They've got these mold problems. Well, again, think about it. If you cover that window with something like a heavy curtain, we're reducing the amount of heat and airflow to that window. So that dew point on that glass, you know, that glass is going to be much colder. So that warm, humid air that gets through that drape is going to condense on that window at a higher rate. So one easy solution is, okay, well, number one, open up the drapes, open up the blinds, allow for heat and airflow over that window. And either A, increase the temperature in the house and increase the temperature of the window surface, or B, reduce the humidity. That's key. Here's another example. Looking for these signs and symptoms of problems. Do we have a whole house humidifier? Oof, this is nasty. Yikes. Okay. Another thing, I'm going to kind of skip through these. There's monitors people use these days to check for like VOCs and pollutants. They've got concerns about them. And science, a lot of the current research is finding that kind of the worst thing for your air quality and your health is fine particulates. And so that is generated from things like cooking. If you're frying things or whatever, just cooking in general can release these fine particulates. And so having proper ventilation in kitchens, like exhaust fans that actually collect that air and exhaust to the outside, are really, really important. Things like smoking or burning candles can also create these things too. So as home inspectors, hopefully, how many, show of hands, I'm curious, how many of you, well, first of all, let's start here. Do you have a lot of natural draft water heaters here that are gas? Okay, I see a lot of heads nodding yes. Do you guys do any kind of evaluation of whether or not they're drafting properly or not? Okay, yep, I see some head nods. People are checking for carbon monoxide. Okay, good. So we see a lot of them up in the kind of Twin Cities area, and it's common for a lot of them to not be drafting properly. And again, this can do with, pressures in the house. If we take a house that was pretty leaky before, and we want to make this house more energy efficient and more comfortable, we decide we're going to do some air sealing. Okay, well, we'll use the rebates through the utility companies. We'll have an insulation company out. We'll do some air sealing in the attic. We'll add some insulation. Great. That seems like a good thing, right? Okay, now we've made the house a lot more airtight. Now that we've made it more airtight, we've got these moisture problems happening. Okay, so let's install some fans. Let's install some bath fans or a new kitchen fan to help get this moisture out so we don't have the moisture problems. Well, now we've just created negative pressures in the house. We're sucking air out with point source ventilation, exhaust ventilation. Okay, so now we've made the house tighter and we've created negative pressures. How do you think that natural draft water heater is going to like that? Probably not so much. Probably not so much. And for somehow, it just depends on the house. Sometimes doing one of those things or two of those things will tip that water heater over the edge and allow it to not draft properly. It's not an issue with the venting. It's not a blocked chimney. It's not any of that. It's the fact that this appliance now can't draft because it doesn't have enough fresh air. Sometimes maybe you can add a larger combustion makeup air. But a lot of times if people are just really, trying to improve their house, the safest thing I found is to just recommend eliminating these natural draft combustion appliances because they are a potential liability. And recommending putting in something like a power vent water heater or electric water heater, or a lot of things are, a lot of rebates are kind of coming out for heat pump water heaters too, things like that. So there's lots of alternatives to a natural draft. Now they're going to be more expensive, of course, but what is your health, worth to you? So this is something I look for and, talk to homeowners about a lot of the times. I'm going to skip through this one. And another thing to watch out for too is when people upgrade the furnace but don't touch the water heater. And if you have like a natural gas furnace and a natural draft water heater that used to vent together commonly up a chimney, and now you take that furnace away and you just have the water heater, we call that an orphaned water heater. And that flue going up, or the B vent going up through the chimney, was sized for both appliances. And the furnace is a much larger BTU appliance. Now you take that away, the water heater is gonna struggle to heat up that flue and draft properly. So, again, a homeowner might think they're doing the right thing. They're putting in a high efficiency furnace. They're gonna save money. But if they're not looking at the big picture and thinking about the house as a system, you can create a new carbon monoxide issue or a health and safety problem with this setup. Okay. There are tests that you can do to see if a water heater is drafting properly or not. I won't get into the details. If we have questions about this, you can talk to me afterwards. But You can do a worst case depressurization test. There's ways to do it quickly in the field. There's organizations that teach people how to do this, and there's all these rules and all these setups, and it takes a while if you're doing it through like BPI or something. But as a home inspector, it's pretty quick. You can make sure all the exterior windows are closed. You can turn on all the exhaust appliances in the house, like dryers, kitchen hood vents, bath fans, anything that will exhaust air out of the house, and then fire up the water heater. Now, sometimes you turn on the furnace as well and the fan, and that will change the pressure in the house too, depending on where the ducts are located and if they're leaky. So that can also impact it. Sometimes opening and closing that door to the mechanical room can impact it too. There's lots of variables and it gets tricky, like I said. But as a home inspector, you could do a quick test just to see, okay, does it seem like this is drafting properly today or not? And also looking for the signs, melted plastic grommets at the top or dark staining. That can be a really good indicator. And I would always mention that in my reports to homeowners. Even if it wasn't backdrafting at the time of the inspection, I would note that and say, you know, there's signs that it could, depending on weather and wind and other pressures in the house, it might backdraft. Or if you change anything in the future, you do air sealing, you add more exhaust appliances, it could create more problems, and be aware of that. Okay. And then we've also got things to think about too, like if we've got an attached garage and people are storing like paints or toxic chemicals in there, a lot of times those spaces are somewhat connected to our living spaces, unless they've been perfectly air sealed, which a lot of times they're not. There's ways you can test that. Again, that's outside of our scope, but you know, those things can make their way into the house. So I have to think about that. People themselves, humans, occupants, can be their own worst enemy. If they're smoking, someone liked to smoke in the bathroom when they were showering, so you can see all the dark staining, the ghosting happening on these rafters here. Or if people, you know, have hobbies that use cleaning, you know, or products, paint, solvents, things like that can create issues. So big picture though, for indoor air quality for people, number one, common sense, right? Remove the source of the problem if you can. That's the best thing to do. After you've removed it, then we can provide some sort of ventilation or dilution. And then after we've done that, we can talk about filtration methods and also kind of what you're putting in your house and material selection. So this is another quote, thank you, Joe. Dilution is not the solution to indoor pollution. Remove the source, add ventilation, and then filtration. Some examples I want to show you real quick of sources of problems people are unaware of. This is a house that has slab on grade and they've got in-slab ductwork. I always pull like every grate off and take a look in there because sometimes you'll find some pretty nasty stuff. All the sand is from evidence of water getting in there and flooding the ductwork. So they've had moisture problems in there before, but then also we've got dead rodents hanging out in there. And just think, you're blowing warm air over all that and you're breathing it in, right? So the house looks clean, but what do you think the air quality is? Not great. And you're not going to fix that with putting in a MERV 13 filter, you know? Remove the source, remove the dead bodies, clean the ductwork. Okay, here's another picture of ductwork that's got standing water in it. Talk about who needs a whole house humidifier when you just have standing water in your in-slab ductwork. Here's an air handler and ductwork that had been retrofit into an old attic. And a lot of times the ducts are leaky. This one is just blowing air right in. But on top of that, those inefficiencies and the leaky ductwork, we've got vermiculite up there. And do you guys have vermiculite here? Yeah, okay, yeah. So in the Twin Cities, the majority of vermiculite came from one mine in Libby, Montana that is known for having, the whole town got shut down. It's a Superfund site now in the 70s because of the asbestos issues with it. So we tell people, you know, it doesn't matter if you test this and it's less than, you know, whatever the percentage threshold is, it doesn't matter. If it came from, you know, this mine in Libby, Montana, then we know it has this harmful asbestos in it and we don't want to be breathing it in. So what happens when you take the air that you're breathing and you run it right through that vermiculite and inject it into your house? Like, again, remove the source before we try to filter anything. remove the source, clean things, remove wet sheetrock that's moldy. Okay, whole house humidifiers, we've talked about this before. Attached garages, tuck under garages with lots of things in them, chemicals. Okay, so remove the sources and then use ventilation. Now, in theory, okay, great. We see a supply register, a toe kick supply register. You guys ever peek down and look and see? A lot of them are not there. They're just blowing air underneath that cabinet, which can create moisture issues in the summertime. If we've got hot, humid air in the house or on an exterior wall that might be leaking a little bit, and we're injecting cold air from the AC underneath that cabinet, it's filling it up. It'll fill that whole cavity with, well, we'll get condensation and moisture underneath there and mold. That can create problems, or even ductwork that's been crushed or not lining up properly. So in theory, we've got the vents there, but is the ventilation actually functioning properly? Probably not. Disconnected ducts and crawl spaces. High velocity ducts that are creating their own condensation issues. Okay, lastly, filtration. Yeah, they speak for themselves. Yeah, love this one. Very effective, very, very effective. And air exchangers, do you guys have a lot of air exchangers here? Not really. Okay, well, we're seeing more and more of them, but homeowners don't know what they are. They have no idea that they've got filters and that they need to clean them. Some people just unplug them too, so that happens. So you may not have filtration. So I'm going to kind of skip through this quickly too, because we're coming up to break time, but there's different ways to provide ventilation to a house. I won't get into the details, but we can have exhaust only, supply only, or balanced. And in general, big picture, balanced is typically the best way to do it. It's sometimes difficult to do in a retrofit, but for new construction, that's kind of where codes are moving to. And for a while in Minnesota, before balanced ventilation was required, builders would just install a continuous run bath fan in the house to exhaust air to provide that air exchange as the houses were getting tighter. That would create a negative pressure. And it basically how that works is it's exhausting air from the house, but it's pulling air in through all the leaks and cracks everywhere else. So if it's hot and humid outside, you're pulling in humid air, making your house more humid. If it's cold, dry outside, you're drying out your house that way. So it can create other issues too. So just a quick high level takeaway, improve that IAQ by just eliminating, first of all, the sources of pollution. Carpet is another big one. Mold spores, pet dander, pollen hangs out in that carpet. So if people have allergies or air, they're concerned about air quality, get rid of the carpet if you can, number one. And then again, get rid of the sources, provide ventilation and filtration. The tighter the house, you also need to think about ventilation. And a lot of times too, we're seeing issues now with, having too much humidity in homes, especially in the South where it's hot, humid climate zones too. They're actually, putting in whole house dehumidifiers now to these houses. And controlling that moisture will help control the risk. And again, we talked about these small improvements people make, air sealing their house, putting in a high efficiency furnace, can create bigger problems down the road. Okay, got a few minutes here. Comfort complaints. These are common things I hear about when I'm doing my consulting work with people about what they don't like about their house. Hot and cold rooms, humidity issues, stagnant air, uneven heating, cooling, odors. What causes these problems? A lot of times it's air leakage, uncontrolled air leakage through the building envelope, or poor insulation, can create problems with heating, cooling. A lot of times it comes down to misaligned. Now this sounds very technical, but I'm going to show you some pictures. Thermal and pressure boundaries, okay, if they're misaligned or not continuous. And also contributing to a lot of these comfort complaints and durability issues are HVAC problems as well. So ductwork that's outside the thermal boundary that's leaking can create all sorts of problems. And I'm sure we could brainstorm a million other things. But again, kind of zooming out, thinking like a building scientist, I like to approach the house and talking to the client and looking at the house for these symptoms that could be a problem, trying to understand the mechanisms, and then figuring out what's the root cause so that we can assess, okay, what is the risk on this, and what are we going to recommend based on that. So it's really just a thought process, getting to know the homeowner if you can. If they're buying the house, they don't know the house yet, but they will certainly tell you what their concerns are. Yeah, we've had problems in the past with mold. We're really worried about that. Okay, now, we're paying attention as a home inspector going through this house. Where could there be moisture issues? What's causing these moisture issues? How do we avoid that? How do we educate the homeowner about that? So going back to kind of a lot of these comfort durability issues, if you do not have a consistent thermal boundary and pressure boundary, it can create big problems. So thermal boundary, what is that? That's basically the insulation. It's where the insulation should be installed to stop that heat transfer in a house. Okay. And then the pressure boundary, another name for it is the air boundary. That is where we want to stop the air movement through that enclosure as well, which is just as important as we've seen for controlling, moisture problems, durability problems, comfort. So if we don't have alignment of these things, then we can have all sorts of problems with heat, air, and moisture moving uncontrolled through the building envelope, creating comfort and air quality, durability problems. So here's a good picture that shows you this yellow line is the barrier between inside conditioned space and outside unconditioned space. And for this example, we've got, let's say it's a cold climate, it's cold outside, warm inside. We want a continuous layer of insulation to stop the heat transfer, and we want a continuous air barrier so we don't have air leakage happening through that building envelope. And we want them, in a perfect world, touching too, continuous and touching. If we have an air barrier, a gap, insulation, that's when we can trap moisture and create problems. So we want them continuous and touching. A lot of times that air barrier could be just as simple as mudded sheetrock that's, airtight. Or a lot of times in a cold climate, it's going to be that vapor barrier, the poly that's been taped and sealed. That's your air barrier. If you use something like spray foam, like a closed cell spray foam, that's going to be your thermal barrier, thermal boundary, and your air barrier at a certain depth. It's going to do both. So just depending on the assembly and the materials, you have to kind of think about, how effective is this? What materials are they using? Is it poly? Are there lots of penetrations in it? Is there going to be air leakage? Or is it spray foam? How does it seem like it's been installed? Do I see any holes and gaps in that? So I like to kind of just take a step back when I show up to a house and think about where should that boundary be between inside conditioned space and outside unconditioned space. So quick example here. This is one of my favorite houses because it's so simple. A ranch. We've got 1950s ranch. Where's that thermal boundary? Between the inside and outside? Pretty simple. And we've got an accessible flat attic we can crawl into. So it makes it easy to go up there and do air sealing, do insulation, make it continuous. Okay, let's take a step back. Where's the thermal boundary and pressure boundary in this house? It's all over the place. Thank you. Very well put. And sometimes it can even be a hot roof maybe where that, thermal boundary's been installed, the insulation's been installed on the underside of the roof deck. It can be very, very confusing, these houses. Or something like this. We've got 2 different levels of attic space that are connected. And then we've got this tuck-under garage with heated space above it. Something like this. Thinking about that thermal pressure boundary, it's tricky. So the more complex a house is, the higher risk it is. The more likely you are to have gaps in the insulation and gaps in the pressure boundary or air boundary, and have that uncontrolled air leakage and heat loss, which then creates moisture problems and air quality problems and durability problems. So in my mind, obviously the simpler, the better. All these fancy things that people pay a lot of money for in high-end houses like dormers and tuck-under garages and cantilevers, when I look at them, I'm thinking, oh man, now we've got potential building performance issues, right? You're paying money for a headache a lot of the times. More angles, harder to air seal insulate. Okay, so another question I ask myself, does every room have proper supply and return as well? Or heating and cooling source? Is the thermal boundary and pressure boundary aligned and consistent? Are these things in place for comfortable space and a high performance space? I love this. What do you think about this? Yuck. We've got this addition that is a cantilever. It's being held up by a couple posts. We don't have a consistent air barrier at all, probably, in these additions. And if you look closely, you can see there's a window AC unit on the second floor hanging out up there. I'm sure this house has central air, but that room just cannot keep up. Maybe it doesn't have its own designated supplier return, but we also have a flat roof over it, so it's probably not very well insulated either. So we've just got all the factors working against it. Inconsistent pressure boundary, inconsistent thermal or lack of thermal resistance in the walls and the ceiling, and then the HVAC is not doing its job, which leads to comfort issues and durability issues. So lots of issues. Okay. Do I need to take a break? Are we have break time? How many? Okay, perfect. We've got 11 minutes. Then we'll take a short break. So here's another example. This was a recent one I did where this was a turn of the century or mid-century modern house in Minnesota, and the homeowners had recently done some upgrades to it. They put on a new roof, and while they put on a new roof, they decided, hey, we'll improve the insulation. This hasn't been touched since like the 60s. We're going to do replace the old fiberglass bats with close-cell spray foam. So they had an installer come and do the close-cell spray foam from the exterior while the roof was off. And they did that. One thing they really loved about this house was the tongue and groove ceiling throughout, which I'll show you pictures. So they wanted to save that. So that's one reason why they did that method of installation. But come wintertime, they had water dripping through their ceiling in lots of areas through the tongue and groove, and they couldn't figure out what was going on. It's the wintertime, why is this water dripping in? Then come summertime, they had the same problem. They had all sorts of moisture issues in the summertime too. So let me show you. These are some pictures of, there's a blower door that's depressurizing the house. It's pulling outside air in. It's hot outside, cold inside. So we're seeing these warm spots showing up on this ceiling, this tongue and groove ceiling. And you can see just very inconsistent the R value in this space. And a lot of this to me looks like air leakage. You can see the fingers happening in a lot of where the roof meets the wall and these other areas. We clearly have an inconsistent pressure boundary and inconsistent thermal boundary in this ceiling. You can see the drip marks and the condensation happening here. So what was going on? Well, I got to talk to the contractor, and he got the spray foam guys on the phone. And it turns out, in order to protect that ceiling and to prevent any spray foam drips from coming through those gaps in the tongue and groove, they decided to put down a cardboard backer on top of it. There's no poly or anything like that. This house was built before that. So it was tongue and groove, fiberglass, roof deck, roofing. So when they removed the roofing, they took out the fiberglass, they put down the cardboard backers and sprayed to that and filled up the cavities, right? And then put the roof deck back on. Well, clearly, now we've got a gap between where the spray foam is and where the actual ceiling is. We've got that cardboard separating it. So we've got channels where that air can flow in between the cardboard and the tongue and groove ceiling. Now, what was creating that airflow? We need a pressure difference in a hole, right? So it turns out this case got to litigation. They ended up taking off sections of roof deck. You can see how the spray foam had pulled away from the rafters in some areas. Okay, so now we've got gaps between the rafters and the spray foam that go all the way down to the cardboard, which then connects to the tongue and groove, which connects to the house. So we've got this pathway for air to flow. So when it's really hot and humid outside in their air conditioning, heat goes from more to less, moisture goes from more to less, that warm humid air is being pulled in, and it's hitting these cold surfaces. They had beams in the house with the air conditioning. That warm humid air is touching those cold surfaces and condensing. So now they're getting condensation in the summertime that they never used to get. And then in the wintertime, the opposite, warm, humid air leaking up, pushing up through all these little gaps and cracks, and it's touching the cold roof deck and it's condensing and then it's dripping back down and coming out to the ceiling. Now, I'll get to your question in just a second. I was going to say, when they had fiberglass, it was a lower R value in that cavity. So you actually have more heat transfer happening, which probably helped keep the roof deck warmer, which probably reduced the potential for condensation on it. As soon as we add a higher R value, we reduce the heat transfer to the roof deck. The roof deck gets colder. So we're more likely to get condensation, frost buildup, and then melting with the new assembly, even though it's an improvement on paper. In person, the performance got a lot worse because of these tiny little issues like this. Okay, question, Sean. Yeah.
Do you think that assembly would have performed if those gaps weren't there? And then secondary, how often do you see this kind of shrinkage with the closed cell?
Okay, the first part of the question, if who wasn't there?
You think this assembly would have performed properly if those gaps weren't there?
Oh, yes. Okay, if the gaps weren't there, I think, yes, it would have had a much better chance of less moisture issues for sure. If we had a consistent air barrier, yes. If it was just leaking between the foam and the ceiling, it's still going to be warm in that space in the wintertime because the foam is, keeping all the heat in. So we'd be less likely to have condensation. So I think really the failure point was these gaps of it pulling away. Great question. And then how often do I see this? I get called out to houses that have problems, so I see this all the time. And it's not to say that spray foam is bad or that this happens in every house. I don't think it does. I think there are applications for spray foam that are really good, and it can be done well. But I also know that it is a science and it's an art to get spray foam right. Two-part foam, you have to mix it, the A and the B properly. It has to be installed properly. You have to be, considering outside temperatures, surface temperatures, humidity levels. So if you've got a company that has a brand new guy they just hired and he's put on the gun and he's spraying, watch out. So that's where I see a lot of these failures. Yep. And I think this was, talking to spray foamer, this was a new foam that they hadn't used before that they were trying out too. So it's hard to say. There was probably a lot of things that went wrong here, but yes. Okay, 5 minutes. Okay, perfect. Okay, another thing about thermal and pressure boundaries, wanting them to be aligned and continuous and touching. Crawl spaces, you guys have crawl spaces out here? Yeah, I see. Okay, a lot of head shaking. So crawl spaces can be a big source of issues, as you know, mold, moisture, structural problems, all of that. And especially if you've got, ductwork running through there. I don't know, do you guys see, are a lot of your crawl spaces vented here? Okay, yes, a lot of them are vented. So, if that space in the summertime is warm and humid and you've got air conditioning ducts running through there, if they're not insulated properly, we're going to have condensation and moisture, and all sorts of air leakage issues and problems. So, crawl spaces can be a big problem. And here's just some examples again of, just bad crawl spaces, especially dirt floors too, all that moisture coming up through the floor and radon, and then kind of getting into that space. And then heat goes from warm to cold. And in the summertime, your air conditioning, you're pulling in that crawl space air into the house through all these little gaps and cracks in the framing. And maybe the ductwork, isn't sealed perfectly as well. So you could be pressurizing or pulling in air from that as well. So whenever I see crawl spaces, I'm just thinking, okay, is the house connected to this space? Most likely it probably is if it looks like this, right? And so how is this impacting the house? Is it the moisture issues? Is it the mold issues, structural issues? And in a perfect world, we would encapsulate our crawl spaces. We would have how many times have we actually seen this out in the wild? Never. But in a perfect world, this is, and hopefully we're seeing more and more of this. I know that there's, depending on what state you live in, the codes are different and the requirements are different. What inspector you get, it's different too. It can vary. But there's been a lot of research done on this, and they found that, especially in humid climate zones, you really want to have some sort of encapsulated and conditioned space down there because your house is communicating with it. So you want to keep it dry, you want to keep it conditioned. So you want to insulate it, you want to seal that the floor, and you want to have some sort of ideally like dehumidification or some ventilation to that space as well. Okay, so the takeaway, simpler for the envelope of the house is better in theory. It's easier to insulate, easier to air seal. You want to keep the inside in and the outside out. Okay, well, this is perfect timing because we're coming up to a break, and this is we're going to dive into some real world case studies here. Real quick, before we take a break, we've got one question. Yep.
I'm glad you mentioned the crawl space issue. I just had a situation where I was called in to investigate a crawl space problem. They said that they had had some work done underneath, and it was a 4-foot crawl space. All the return air ducts are below, all the piping, all the sewage lines.
Yep.
The utility companies had come in and sprayed foam spray on all the walls. They put a heavy duty plastic on the dirt, which I thought was great.
Yeah.
But they covered it with the vents. And they said suddenly after they had this done, their house started smelling very musty. Well, I could see that it was being drawn in by the return air, but they were asking me about the vents. Should the vents be opened or sealed up? And anybody here who's run into this, I'd like to hear from you, because I wasn't sure how to answer that question. Myself, I probably would have opened the vents up again, but I said I needed to investigate. And this was only just a couple weeks ago.
Yeah.
Yeah, that's the problem. It
You stole
depends.
my line. Yeah, that's a good point. So crawl spaces are so tricky. And if you, I don't know if they originally had insulation up against the underside of the flooring there, but I mean, a lot of times there's tons of mold and moisture because of that. And so again, removing the source first, trying to clean things up before you're bringing that inside the conditioned living space is key. In theory, if there's no mold underneath the structure of the house and they've air sealed and insulated the walls and the floor, we shouldn't be smelling anything musty per se, but that's hard to say. If the ductwork is pulling air from that crawl space and it's not clean air, then you're getting that into your house. So, I'd say you want that space to not have issues with mold in the wintertime. So you want a little bit of heat to it. You want some sort of heat source to it. In the summertime, you ideally try and keep it as dry as possible so you have some sort of dehumidification going to it as well. So crawl spaces are tricky, and I think it depends on the house. It depends on the homeowner's sensitivities as well to things like that for air quality. I don't have a one-size-fits-all answer. Sorry. Yes. Okay, great. So this is kind of the first part of the presentation is like laying the groundwork for everything, like, thinking about heat, air, and moisture flow, recognizing the symptoms and the signs and what does that mean and what's causing that, risk assessment. The second half of this presentation is looking at like real life houses and problems and issues and diagnosing them. So this part I think is the fun part. Hopefully you guys do too, but feel free to chime in if you guys, again, online, if you've got questions, you can type it in the chat or here in person, raise your hand, use the mic. So let's get going here, applying the house as a system and the lessons learned. So here's a first case study. This was a house that was built in 1978. It was in kind of outside of the metro area of the Minneapolis-St. Paul. And this homeowner contacted us because she just had this musty smell. She could not figure out where it was coming from. Wasn't a crawl space, I'll just say that right out. She had a full basement, but could not figure out where it was coming from. She had all these different people, contractors come in, and they just didn't know what was going on, and she was feeling overwhelmed. Also had people tell her she was crazy too, which, you hear that a lot. I take pity on that. No, none of the other inspectors wanted to deal with someone who, had a complaint about a smell. So having sensitive nose, I was like, okay, I'll take this one. And it's pretty interesting. So I'll go through some things here with you first. Again, I like to kind of just get the lay of the land and try and understand the house as a system. And I do that first by doing just a visual inspection of the outside and the inside from, top to bottom. And so when I'm walking around the outside, again, I'm kind of focusing on, these potential low-hanging fruit things like, is there bulk water intrusion? Number one, that can create musty smells if we've got water leaks happening. So where is the water going? What does the grading look like? What is, are there downspouts and gutters? What does that look like? So here's just kind of some different shots of the outside of the house. You can see kind of some of the grading here, and here's another shot. The grading actually kind of sloped towards the house in some areas. It was flat in a lot of spots. Here's some more. We do have a full system of gutters on this house and downspouts. Some of the downspouts didn't extend very far though, and a lot of them were clogged with leaves. You can see all the leaves in the gutters and leaves in the downspouts. So probably not the most effective there. Okay, I'm inside the house now, and I'm thinking about the thermal boundary and the pressure boundary. Remember that picture with the blue and the red house, the yellow line that was separating hot from cold and conditioned from unconditioned? Okay, now when we have a house that has a full basement and they've got portions that are finished and they're living down there, do we want to separate the basement from the first floor in terms of conditioned space? No, right? We want heat and cool and conditioned air to be kind of circulating through that house holistically, basement, first floor, all of it, right? So should we have insulation in that basement ceiling, separating those two spaces thermally? No. Good, yay. You guys were listening. Okay, someone has a question, yes.
And also, if you look at the insulation's upside down.
Yeah, we got all sorts of things happening here. They didn't do a consistent job either, did they? They missed some. Okay, so here's some more. Some without the paper backing on here. Okay, we also have little areas, like here's a kind of a little room that used to be an old well room that is blocked off. There's really, no air circulating to it at all. Here's another shot. This was a bathroom in the lower level that had been finished. Just taking closer looks. What would you get? Does this wall look dry to you? No, there's lots of head shaking. No, it's, this was sheetrock and there's, paint's peeling and it's not looking great. And actually, conveniently, there was a loose section of drywall here. And so she allowed me to kind of pull it back a little bit, and I did a little bit of digging. Usually all my inspections are non-invasive, but she was like, yeah, do what you need to do. So kind of looked into here. So there's poly behind the sheetrock, a vapor barrier, plastic, and then we've got fiberglass bat with the paper backing, which is another vapor barrier behind that. So now we've got a double vapor barrier. And to make it worse, that's, on the backside of a concrete block foundation wall with flat grading or negative grading and clogged gutters, okay? Taking a little bit further look here, kind of just, again, walking around, looking at the mechanical systems. We do have a combustion makeup air duct, but peeking up underneath it, there's something blocking it. Looks like someone has stuffed some insulation in there. Okay, and inside you can see that's where the duct is. It's behind that natural draft water heater. We also notice the furnace has been upgraded. And we've got a high efficiency furnace. We've got a natural draft water heater. Just kind of putting all the pieces together. And there were no supply registers down there. And they're finishing this basement. So they're using it. They've got the bathroom. They've got a living space. And they have, there was one supply register by the furnace, by the trunk, but it had been also taped and sealed shut. So no source of heat down there. And they're thermally isolating it from the upstairs. Okay, looking at the rest of the house, how about ventilation? No bath fan. It was not that cold outside that day. It was probably like in the 50s. And there's condensation on the window, on the glass. And even worse, there's condensation on the frame too of the window. So lots of moisture in this house. Okay, digging a little bit further, the concrete block was open core, hollow core block. And so I just stuck my hand up there at the top of the wall. It was unfinished, and I could stick my hand down into the cores. Okay, so that just means we've got potential, pathways all the way down to the footings, to the soil for that air and the moisture to come up through the blocks and dry to the inside or come to the inside of the house. So this could be a source of radon, could be a source of moisture into the house. Okay, so just a quick summary here. We've got no bath fans or kitchen fans. The combustion makeup air is blocked. The heat supply is closed. We've got double vapor barrier on a below grade wall with poor exterior water management. And they'd also just done spray foam in the rim joist of the house because they're trying to make it, more energy efficient. I'll get you in 1 second. Another quick thing I want to add, another person just moved in the last year. The gutters and downspouts were added just in the last year. So the house didn't used to have that. And they had just put in new windows and new siding. So the new windows made it more airtight. And also she mentioned that the AC kicks on and goes off real fast. And so we know a lot of times AC systems or furnaces, they're oversized, right? And so when they're oversized, they're going to kick on, satisfy the thermostat really fast, not run long enough to dehumidify the house, leaving the homeowner feeling cold and clammy, right? Well, that's probably what's happening here. Okay. Question. Yes.
In the second picture of that, you don't have to go back, but the
Okay.
second exterior picture, you had like 2 or 3 windows at grade level without window wells.
Yes, good point. Good point. Yes, no window wells on the windows. Yep, that could be an issue too. Good eye. Okay, so diagnosis on this house. We have reduced air exchange because we have new windows installed, right? We did spray foam at the rim joist, making that house more airtight. And we blocked off the only fresh air into the house. So we made it a lot more airtight, reduced the air exchange. And then also, we don't have any ventilation in the house. And we added another person. So, people generate moisture, showering, cooking, breathing. We added another person. We've got poor airflow, poor potential sizing of AC. And we've got this wet foundation with a double vapor barrier on the inside. And it can't dry out, right? So all these things combined, like this picture, the perfect storm. Okay, this house is on the edge. So, okay, here's my thoughts on this to see if you guys have any additions. But we need to remove the sources of this potential musty, moldy smell first, right? So clearly we've got moisture in the sheetrock and probably in the insulation that's up against this porous concrete foundation. So we got to get rid of any material that's holding that moisture and could be moldy and wet. So that would be my number one recommendation, which people don't want to hear, right? Because who wants to, take apart their finished basement? But if you're sick or you're dealing with this smell and you cannot get rid of it, that's what you got to do. And okay, so how do we prevent that moisture from coming back and being a problem again? We need to improve the water management on the outside, right? So improve the grading, get a positive slope away from the house, clean out the gutters, make sure we've got the extensions on. They're taking the water away from the foundation. When it comes to the actual, air in the house, we need some sort of ventilation too, because we made the house a lot more airtight. So we need to, install some sort of point source ventilation in places like bathrooms for sure to remove the moisture from showering. Ideally the cooking too, we need that as well. And then we should open up that combustion makeup air for sure. And we have that natural draft water heater. So just, I'm concerned about potential backdrafting as well. We should open up that supply register in the basement so we get conditioned air down in that space. We get mixing of, the air and heat supplied to it as well. Yes, question in the back? Or
What
a
I find
comment?
most common is supplies in basements, but no return.
Yeah.
How big of a deal is that? I kind of express it as a big deal, but I don't know for sure.
That's a great question. Um, a lot of basements where, in the Twin Cities area are supplies as well. I think if the homeowner is not having comfort issues, I wouldn't make a big deal about it. If they are, then you can hire an HVAC contractor who does manual J's and heat calcs and everything like that to come in and I would say assess the space and see what the calculations say the space needs if they've got comfort complaints or air quality complaints. Yes, question.
Is it beneficial to keep the blower motor on at the thermostat? You know, because you can have blower motor on or auto.
Yeah.
I keep mine on all, so the blower motor continues to spin even though the AC is not on or the heating system is not on, but the blower motor continues to circulate the air throughout the house.
Well, how much time do we have? Because that's a very
That's
complicated.
okay.
Yeah, I was gonna say, so it depends. And if you've got a house that has ductwork outside of the thermal boundary, like if it's got ductwork in a tuck under garage or an attic space or exterior walls, and that ductwork is not perfectly sealed, you're gonna be leaking conditioned air to the outside. And what happens is that you're pushing that conditioned air out, you're pulling other air in, so you can create other pressure problems in the house. And if it's hot and humid outside in your air conditioning, you can pull humid air in. Wintertime, it's the opposite. So I used to think that was a good thing to do if you're just trying to mix the air and make it more comfortable. The more I've learned and the more I've hung out with HVAC people and physicists at like the Energy Conservatory who make the equipment that does the testing, I've learned that like duct leakage is a big problem and it creates lots of comfort problems and durability issues potentially with moisture. So it's never a simple, it's a good thing or it's a bad thing. I think it depends on the house and the location of the ductwork and how leaky the ductwork is and what the problem is you're trying to fix. And I'd say you could play around with it. If turning on the fan seems to make the house more comfortable and consistent, okay, keep it that way, do it. If it doesn't, well, then there's something else going on and we need to add more supplies or add more returns or do something like that. It needs a better evaluation of the HVAC system. Yeah, question.
Kind of a follow-up. Would ceiling fans and box fans, people using in the house have the same effect as that, or is that just more circulation and we really don't have those problems using those to circulate air?
Yeah. I think again, depending on it's the homeowner that drives how big of an issue it is a lot of times with comfort. Who are we to judge if it's comfortable or not? They're going to move in there and if it's comfortable to them, great. The ceiling fan is going to push the air around and maybe mix it more and help with striation and stuff too. Yeah.
Referring more to just the pressure, differences in pulling air in.
Oh, gotcha. Pressure differences. Yeah. So yeah, the ceiling fans in theory are not going to change the pressures like having the fan on the furnace. You're right. Mixing the air if you've got duct leakage happening outside the thermal boundary. So, if you've got ceiling fans, that might be a good alternative if you're worried about your duct system not being perfectly air sealed. That's a good potential solution, to push air around. So she's got a lot going on in her house, but again, this basement's not getting adequate heat supplied to it. It's not getting adequate airflow. It's being thermally separated from the upstairs conditioned space with the insulation in the ceiling. It's got a double vapor barrier around a porous concrete foundation wall where water's leaking in. We don't have proper combustion makeup air for a natural draft water heater, and we've made our house tighter. And on top of that, they've put in a new high efficiency furnace. So, they've orphaned this water heater. And one thing we didn't talk about earlier, but when you take like an induced draft furnace, one that had a metal flue that would vent up through the chimney, and you replace it with a high efficiency sealed combustion furnace, you've also changed the pressure dynamics in the house because the old induced draft furnace would use air from the room for combustion, okay? And then all that air goes up the flue. So you're actually creating this natural kind of air exchange. In the wintertime when that furnace is running, you're pulling in cold, dry air and as that hot exhaust air is leaving. So that's creating a natural air exchange and kind of drying out the house. So you've got this kind of natural dehumidification happening using an induced draft, furnace. When you replace that with a sealed combustion furnace, especially if you've got the two pipe system and the intake is going to the exterior. It's pulling in air from the outside, directly using that for combustion and exhausting it to the outside. Well, now you're not creating a pressure differential in the house. It's just drawing air from the outside. So you're not getting that exchange of air happening in the house in the cold weather like you used to. So now all that warm, humid air that you're generating in the winter is just staying in the house. It's not being exchanged. So not only did she make her envelope more tight by doing the spray foam and the rim joist, the windows, sealing up the combustion makeup air, but replacing that furnace with a high efficiency furnace is going to also make the humidity and moisture build up in the house more too. So it's kind of a double whammy with the mechanical system and the envelope upgrades, making the moisture a bigger problem and not having proper ventilation in place. Now, what's going to happen when you recommend to deal with this moisture and all the condensation on our windows and this moldy, musty smell? What's going to happen when you recommend adding bath fans and a kitchen fan to this house? Is that a good thing or a bad thing? It depends, right? Now you're thinking like a building scientist. Sometimes it's very unsatisfying because there's not a correct answer. So it's good because now we've got, this ventilation happening, the moisture being removed, the pollutants being removed, but we potentially could be creating a negative pressure, and we still have this natural draft water heater in the basement that's susceptible to pressures, right? So if it's not already backdrafting, adding a bath fan or two, or two fans and a kitchen hood vent could tip this house over the cliff and create backdrafting in the situation. So we have to think about the house holistically again. We want to provide heat supply. We want to provide ventilation, but we don't want to create more problems through doing these other things. So we have to talk about the water heater and probably replacing that with a power vent or electric or heat pump or something like that. So she's like, my house is musty. And I'm like, well, replace your water heater. It's like, what? But all these pieces come together, right? And you can't treat this symptom without thinking about the whole and how they're all going to work together or not work together. And ideally, in a perfect world, because she's upgrading this house and making it more airtight, and we've got the sealed combustion furnace and the new insulation and everything, and she's sensitive to smells, I would recommend even doing something like an ERV or an HRV, some sort of balanced whole house ventilation system. You still want to have point source ventilation, remove contaminants and pollutants from like showering and cooking, but it's a good idea to have like an ERV or an HRV that can be running continuously as needed to provide that fresh air, and it will also filter the air too at the same time. So I think that would be a really good solution for her. So zooming back out again, the systems thinking. In building science, they say order matters. So how you do these upgrades on an older house really, really matter, the order. So air sealing without adequate ventilation can create these moisture problems. Finishing a basement before addressing the exterior water creates more problems, traps moisture. Adding point source ventilation could impact the water heater and how it drafts and create safety issues. So again, it's just a perfect example, I think, on this house of how we've got all these different variables and all these different systems interacting. We need to think about the house as a system in order to solve her problem, what's going on. Okay, any questions about that? Okay, yes, go ahead, Sean.
Do you like prioritize your recommendations? Because if there's 15 things,
yeah,
is it like try this and then see if it works and then try this and then try this? Or
that is a great question. Yes, I do. And I would say what I do now with my consulting business, Your House Coach, is I talk to the homeowner and I get to know kind of what their concerns are, what their problems are, what their budget is, and how long they're going to be there. Someone that's going to be in the house for 20 years versus someone who's planning on moving in a couple of years will really vary kind of my recommendations for them. And also, their budget too. So it's like, let's figure out what's going on with the house. Okay, here's the ideal blueprint for what we would do to it. Now let's apply it to your situation and what makes sense. And a lot of times it's some kind of, level of, well, this would be the best approach, but you could try this. And then let's see if that works. And then if it works, great. We don't need to do these other things. And sometimes it's, well, let's try this. If we add these bath fans, let's test your water heater again. If it seems to be doing okay, then fine. We just do a step-by-step approach on that. But yeah,
So it depends.
it depends. You got it. I just need like a sign where you just hold it up. It depends. Okay. So this house is just a perfect example of, this is a analogy that my professor at the University of Minnesota, my building science professor, Pat Hellman, used to say, the cliff analogy. So the house, as you're doing these incremental improvements to it, you're moving it closer and closer to the edge of the cliff, which once it tips over the edge of the cliff, we've got failure. And it could be anything from a backdrafting water heater to mold and moisture to other issues. So these incremental improvements can create unintended consequences. And we avoid those by understanding the whole house as a system. Okay, let's move on to case study number 2. So this was a house in about an hour outside the Twin Cities, kind of along the Mississippi River. And it was built in the 1920s. Beautiful brick home, you can see. We got the nice large overhangs protecting the walls, beautiful design. But the homeowners contacted me because they were so frustrated with their utility bills being extremely high. And this was about, I want to say probably about three or 4 years ago. It was about $800 a month, maybe up to $1,000 a month to heat this house. It's about 2,600 square feet, and they were uncomfortable at the same time. So they were cold in lots of different rooms, and I'll kind of walk you through so you can see. So their goal was to try and improve the energy efficiency, and they wanted to make sure that the house was still sturdy and strong, and it had maintained its property value at the same time. So that was their goal. Okay, here's some background information. So they were not aware of these comfort issues and the high energy costs before buying the house, despite having a home inspection prior to purchasing. The report did not mention lack of heat source to kitchen or a leak, a roof leak that they had, a couple roof leaks that they had. So backing up though, we're in a tricky spot because we're not required to report on comfort issues, right? We're not required to report on energy efficiency. But as you can see, when people move into a house, if they're not comfortable, that's a problem. And they're like, why didn't my inspector tell me about this, right? You inspected the house. This is important. Why didn't you catch this? So again, I'm not saying it's our job to do that, but I think, if we're informed and we're thinking about the house as a system, when we're evaluating these things, thinking about the thermal boundaries, the pressure boundaries, do we have heat supplies, supplies and returns, we can kind of put together, okay, this house might be a little bit challenging to be comfortable in. And we can have those conversations with the homeowner. Hey, have you ever lived in a 1920s house before? Well, here's what I'm noticing, okay? These things, this could impact the comfort, and it would probably be more expensive to heat and cool than the 2000 townhome that you were living in before coming here, and at least kind of plant the seed. And maybe they can reach out to the homeowner or the realtor and ask and see if they can get utility bills and at least get informed that way on what they're getting into and what they're saying yes to. Also, this is kind of sad, but the clients had spent their entire budget and their savings for the house on doing kind of piecemeal improvements that they saw were necessary along the way, which I'll show you actually kind of added to their problems. And then prioritizing the remaining repairs, maintenance, and improvements based on their budget, potential ROIs, goals, and necessities. Okay, so that was what we were trying to do, is figure out what could be done to make it better and how to prioritize that. So let's look at the list of improvements they did once they moved into the house. Well, they moved in and they had water intrusion from ice dams that very first winter. welcome to your new home. So what they had to do was they gutted the room that had the water intrusion, and they replaced the sheetrock. So they had to remove it, and then they put it back up. They also, that room was very cold, so they added electric baseboard heat to that room too. So let me show you what that room looked like. Here's the back of the house. Had a walkout basement, so it's like 3 stories with a walk-up attic and that little dormer on the back. But that office was the room that's highlighted here in the box, and that room was cold. And so they added electric baseboard heat to it to try and make it more comfortable because they spent a lot of time in there. But the sad part is, they had water intrusion from ice dams, and all they did was, have to tear out the finishes and then just redo the finishes. So that's what they did. The question is that cantilevered? So that room actually has conditioned space directly below it, which is the kitchen. It's like a little eating nook off the kitchen. So technically, I would say probably not a cantilever, but it does bump out. So, it's got unconditioned space on 3 of the 4 walls, which will definitely impact, comfort as well. Yes, question.
So the room does not have condition, it doesn't have an HVAC source to it.
Yes,
It's
correct.
just the electric base. Well, the person should tell him baseboard heat is going to make your meter spin like a top.
Yeah, exactly. So, anyways, this was, they had the house inspected. Those, the issues with the heating cooling was not brought to their attention. So then they're trying to add supplemental heat to these spaces that felt cold, and they just hire someone to come in and put in what, the easiest thing, which was electric baseboard heat. This house was boiler heat, by the way. Oops, let me go back to it. Boiler heat. So I think there was one radiator kind of in between like that, where the original like rectangle of the house is, and then where that bump out for the office is, that like there was a radiator there, but not all the way out on an exterior wall for that office space. So it just wasn't adequately heating it. Okay, another question I want to ask to you guys though is, okay, if you're driving down the road and let's say it's really, really cold outside and you have your windows rolled down all the way, do you want to add a bigger heater into your car first, or do you want to roll up the windows? Okay, so my thinking is, okay, so do you think there's any insulation in this attic? I don't know. So we'll get to that, okay? So here's what that room looked like once they refinished the ceiling and they added the nice electric baseboard heat, okay? Going back to their improvement list, let's add to it. They added a bathroom off their bedroom. They turned one of the bedrooms into a bathroom, and they added a laundry room to that. Oops. So they spent a lot of money making that a nice bathroom with a washer dryer. Yes. Question or comment?
The, that bump out, that second floor, had that been a sleeping porch? And maybe it'd been enclosed and they had no insulation in the attic?
That's hard to know. It's a good thought. And I see that a lot in houses where they'll convert a space that used to be unconditioned to a conditioned space. There's not adequate insulation or heat or cool supplied to it. So it's very possible that it could have been, and likely too. Don't know for sure.
2 back.
Mm-hmm.
That, forward, there. If that's that room, that's the second floor?
This is, well,
that's
basement,
bumping
first
out
floor,
into
second
it?
floor. Mm-hmm.
Yeah, it looks like it's all framed, that they had a window and doorway into maybe an unfinished space.
It kind of does. Yep, it does. With those little kind of half walls separating that space. Yeah, it's very, very possible and likely. Yep. It's good thinking, because again, you're kind of thinking about where's that thermal boundary and pressure boundary, and originally that thermal boundary was probably on, where the back of that house was, not all the way out to this office room. Yeah.
Yeah, and its original intention, if it had been an unfinished space.
Exactly. Yes, you bring up a good point. Thinking about what's conditioned, what's not, and if they converted that, they would have some issues. So, okay, they spent money on the bathroom, finishing the bathroom. with laundry. They didn't like the location of the electrical panel where it had been in the basement. They wanted to do some work down there. So they moved their electrical panel. That cost them a lot of money. They also decided to add some, quote, in-floor heat, they told me, to the kitchen, the breakfast nook, which was directly below that office that I just showed you. That room felt cold to them too. So they added in-floor heat, and that wasn't enough. So then they added electric baseboard heat to that room as well. So that's this space right here. Here it is. Now, if you look closely on the underneath that window on the right, there is a let's see if I can. It's hard to see with this. It's pretty bright in here. There is a white floor register right there underneath that window. So in all honesty, I mean, if you're a home inspector and you're kind of going through this house, you know, you may not think much of it, but that was not connected to anything. There was nothing connected to it. Don't know why it was there. Again, this house was boiler heat. So hopefully as a home inspector, you can connect the dots there. Yes.
So where it said the in-floor heating on was that electric radiant, or would they have a boiler, or was it hydro?
Perfect question and timing. Let me show you. This was their in-floor heat. So they had the person who worked with the boiler come out and just do a couple more runs with the piping through the floor joists underneath that spot. That was their, quote, in-floor heat. So I wouldn't really call that in-floor heat. They just ran some hot water tubes there, and it was clearly not effective. So then they added this. Yep, another electric baseboard. Okay, you can see where all their money is going. Too bad. Okay, here's another upgrade they did. They decided to finish part of the basement. So they did closed-cell spray foam on the exterior walls and finished this space down here, which looks really nice. And you know, to give them credit, these homeowners were proud of their house, loved their house, and also wanted to do the right thing and take care of it. And so, you know, they tried to do things to the best of their knowledge the right way. They used closed-cell spray foam, right? Which cost them more money doing things like this. Okay. Couple more things. They added a new EPDM rubber membrane on the back flat porch right here, which had a lot of pooling water right here. And also evidence of water intrusion from that. I'll show you in pictures later. And I think the last thing they did was they installed this metal ceiling underneath the back porch to try and collect the water because, you know, they didn't want to have water dripping down and freezing and making a slip hazard for themselves. So they did this big deck. They did this ceiling underneath the whole thing to try and catch that water. So here's pictures of that. Okay, you had a question here in the front.
Yeah, I was just curious, a couple pictures back.
Uh-huh.
Where you're talking about spray foam.
Sure. I'll go back to the basement here.
Is that under the kitchen, under that?
It is. You're
Is
right.
that where the vent would have, the past
Yes.
vent would have been? 'Cause it looks like it had a water heating? Hot water
Well,
heating?
it turns out they might have had some sort of like other furnace that was there at some point, or a stove or something. There was some.
So that was that what used to be a pass-through?
It could have been. It
But
could
it's
have been.
blocked up here. They blocked it up, right?
Yes. Yeah.
Okay.
Well, yes, and everything's been finished, and there's no heat source connected to that duct or anything like that. That grill just opens to floor cavity space now.
Okay.
Yep. Yep. Okay, let's see. So they replaced the flat membrane. They still have water leaking. They did the metal ceiling. Let's see. Oh, here's they've repaired, quote unquote, the rotted wood on the back porch. Okay, and you can see the paint is still bubbling there. It's kind of getting depressing, isn't it? Yeah, it's a big house. There's a lot going on here, and there's nobody to help guide them on how to prioritize things or what to do. Here's another thing that happened once they moved in. They had a AC line that got clogged, and the air handler was in the attic, and so it leaked and it ruined the ceiling upstairs too. So they had to replace the sheetrock upstairs as well with that issue. And they also had a flex duct with a dryer that another contractor caught. So they had to replace the duct for the dryer with something, and they insulated that and they put that through the roof. So here's a shot of their attic with their air handler duct, all the duct work running up there. It's just kind of a mess going on. There's their condensate line that got clogged and flooded. So, okay, some additional information. We've got a complex design. We've got, turns out, 3 different attic spaces. Okay, I'll show you a picture of what that looks like. And only one of them is accessible. And we have a tuck under garage. So remember, simpler is better when it comes to being able to control heat, air, and moisture in a house and the building envelope. So here's another kind of angle of this house from the back. And you can see, okay, we've got the main upper attic up here, which is the only one that's accessible, and it's a walk-up attic. And then this is the little attic space above the office where they had the ice dams, and there was no access into that. And then there's another separate little attic space over their sunroom that's conditioned down here. And then we also have a tuck under garage underneath the house too. Okay, so we got complex thermal pressure boundary house going on. Dormers, tuck under garages. Okay, going into the walk-up attic, the only accessible one, there was no insulation. So what do you think the inaccessible attics have? Probably not much. So here's what it looks like. Okay, we have a lot of older houses kind of in Minnesota and in Red Wing area that have walk-up attics like this that have a planked floor deck. People use them for storage. I don't know. Do you guys have houses like that here? I see a lot of head nods. Okay, so where is that thermal boundary? Where's the dividing line between inside conditioned space and outside unconditioned space? The ceiling floor, maybe, I mean, maybe there's some insulation underneath those deck boards. Maybe. Doubtful though. But what's interesting is we've got all this ductwork and air handler up there, carrying conditioned air. So in a perfect world, would that ductwork, carrying conditioned air, and the air handler be inside or outside the conditioned space? It should be inside the conditioned space in a perfect world. And also, if you look closely too, I mean, this house had roof vents. Let's see. It's hard to see because it's so bright in here, but yeah, there's a roof vent. Yeah. We don't have any soffit intake vents in this house. There's no soffit intakes, but we have roof exhaust vents. So one thing I learned from the homeowners, they didn't have any exhaust fans in this house, no bath fans, except for the new bathroom that they did in there on the owner's suite. But they didn't have a kitchen exhaust fan, anything like that. And the homeowner told me, well, when we burn stuff, we just open up the door to the attic. Okay, think about stack effect, right? In the wintertime, especially, this worked well. When they would burn something in the kitchen, if we've got literal holes in our roof fence, and we have a connection directly to, the whole house, we just got a big chimney. And so, all that warm air is just going whoop, right up through the attic, through the roof, and we're just paying to heat the outdoors. Okay, even if you close the door to the attic, obviously we have a lot of air leakage happening in this house. It's just going up and out. Okay, so no attic, insulation, undefined thermal boundaries, and then on top of that, okay, they're concerned about the comfort of this house and high energy bills, right? But top priority for me is always durability structural durability of a house. If we've got a house that's got active water leaks and moisture problems, that's always number one to, comfort and efficiency. So I have to kind of talk to the homeowner about that. Okay, you have an active leak happening here. You can see they were aware of that, but in their minds, it wasn't as important with a bin that's catching all of the water. And this is a close-up of what that looks like. And I don't know if this is the same HVAC contractor who did the other things in this house. I don't think it was, but this is where they put the retrofit AC system in this house. Because remember, it's boiler heat, so they wanted to add air conditioning. So all the ductwork went in the attic, the air handler went in the attic, and then the condenser went on that little tiny flat dormer up there, which, is leaking as well. Yeah. Yeah. Okay, so we got water intrusion, driving rot. Okay, on top of that, there's something very interesting going on that was kind of unique to the way houses are built that I was used to seeing. When I was in the attic, I was looking at the exterior wall tops, and I was like, that looks different than a standard exterior wall top that I'm used to seeing. What is that? And I did a little bit of research, and it turns out what we're seeing is the very top of a clay tile exterior wall. It's not wood framed. Do you guys have anything like that? You probably have just brick, solid brick, maybe in some of the really old houses. But this is what it actually looks like. I found this old picture online of how they would do this. And so it's a structural clay tile that then gets like filled with grout or concrete or something, and the rafters sit on top of that. Here's another image of that. Yeah. Okay. Yes. So you see them in basements. So we see these in basements sometimes too. And I found out that in Red Wing that they manufactured a lot of these clay tiles. So a lot of the houses around there have these clay tiles either as the foundation or maybe even as the structure. So this house had kind of solid masonry exterior walls with lath and plaster on the inside. So we've got thermal mass there, which kept the house nice and cool in the springtime. Like, when it's starting to get hot outside, but the house is under this shade and we've got this large thermal mass, it takes a lot to heat it up. So it would stay cool for a little while, and that's kind of nice. But then after the house had been, sitting in the sun for a long time, it's been hot for several months, it was really hard for them to cool off this house. It held a lot of heat. And we don't have, the kind of R value we would have with insulation in the walls either. So it was behaving differently. And then on top of that, additional information, we've got just kind of these heating and cooling systems that go outside the thermal boundary. As I showed you with the AC in the attic, that's kind of outside whatever thermal boundary should be there. We also have a tuck under garage that has pipes for the radiators running through that tuck under garage. The tuck under garage it's not really conditioned, but it's kind of getting heat from just the heat loss off the pipes that's delivering water to the spaces above it. So the comfort and the energy efficiency are linked in this house for sure. Here's some more pictures of the kind of the heating cooling that's outside the thermal boundary. So the attic space, and then going into the garage from the basement. This is the garage space, and you can see the copper piping that's at the ceiling that's not insulated or anything. That's running through this, quote, unconditioned, cold tuck under garage and running up to the sunroom up above it. And we've got another room that's below the sunroom that's not heated, that would make that space feel cooler. So here's some additional observations we made, just summarizing everything. We've got active roof leaks, the upper dormer, and that lower flat roof back porch area. The boiler's also 18 years old, and it's 80% AFUE. We have a natural draft boiler. The water heater is 5 years old. The AC unit is 13 years old. The water softener doesn't work, needs to be replaced. We've got a garage floor, driveway that slopes towards the tuck under garage and a garage floor that slopes towards the house. So every time it rains, they have water pooling and it's kind of starting to eat away some of the structure of the concrete in the garage. We have old plumbing in the upstairs hallway bathroom that they don't use because now they've got the new bathroom, but those pipes are corroded. They're galvanized steel and they've got rust holes and they're leaking. They have only one bath fan in this house in their new bathroom that they added. So I'm concerned about a lot of things. Clearly, in this house, it can be a little overwhelming, right? Where do we start? And also, they reached out to me last year. They had some questions, and they noticed they had water leaking after a heavy rain in their finished basement, coming out from underneath the framed wall that they had just built. And it was leaking underneath the wall and running across the floor. Luckily, to a floor drain that wasn't that far away. But their newly finished basement was getting wet. So, diagnosis. Again, their main goal was to reduce their utility bills. But we've got these complicated building envelope, things going on with the sunrooms, the tuck under garages, the walk-up attic. We've got these heating, cooling, distribution, and mechanicals that are located outside the thermal boundary. We've got, added electric resistance heat and still have comfort issues. We've got an uninsulated walk-up attic with roof fence. We've got no access to attic spaces that are above the spaces that have ice dams and are uncomfortable, and the sunroom. And the house is just built differently with these structural clay tiles. There's no insulation. So all these things added together are what's contributing to this house being very uncomfortable and also very expensive to heat and cool. And again, none of these things are really, as a home inspector, you're reporting on how much insulation there is. And, there's no attic access to this space. But that's it. It ends there. So homeowners left to their own devices to kind of read that and be like, what does that mean? If they do, if they think that way, most homeowners don't. So I found it very important to, again, get to know the homeowner, ask them what their concerns are going into it. And when I see a house like this and I'm noting all of these things, that then I'm putting the pieces together and talking to them about that. Okay, have you ever lived in a house that's 100 years old? Have you ever lived in a house that's structural clay tile walls, that's not wood frame and has no insulation? Have you ever lived in a house that has an AC handler and ductwork outside the thermal boundary? And do you know what that means and how it can impact efficiency and comfort? These spaces don't have attic accesses. I don't know what's up there. Your main attic doesn't have any insulation. These probably don't either. So these are all conversations you can have that I think probably better inform the client, make them happier, they trust you more, and you're building your credibility. You're not saying anything that's going to get you sued. You're just helping them be aware of what they're buying so they have realistic expectations going into it. So here was my kind of big zoomed out plan recommendation was number one, again, structural integrity of the house. So we need to stop any sort of active water leaks, number one. We've got to fix that. And then number two, in this house, air seal and insulate attic spaces. Now, this can be argued. The order matters, but if you talk to my building science professor, he would say, you always want to make sure you've got the proper ventilation in place before you do the air sealing, right? Because we don't want to air seal and create more problems, moisture problems. But for this house, it was so big and there was only 2 of them and they were using the one bathroom that already had the fan. I was like, okay, in theory, you should have another bath fan here. You should have a kitchen fan here. Do they want to spend, another $5,000 doing that? Probably not. The biggest bang for their buck is going to be trying to keep the heat in the house, by air sealing and insulating that attic better. So for me, I would say let's do that, but also let's just be aware maybe you'll need to add some ventilation after we do that because we're going to make the house a lot more airtight. There's not going to be that natural air exchange anymore. You're not going to be able to open up the door when you burn something and let all of that stink out. it's gonna behave differently. So be aware of that. We'll insulate and air seal the attic, but you might need to add ventilation after that too. And then if we add ventilation, it might impact your natural draft water heater and your boiler. So again, as you asked Sean earlier, kind of how do you approach this? Usually I'm just sitting down at the table with homeowners and I'm explaining how all these pieces connect and say, okay, here's your main focus. I think the biggest bang for your buck is going to be doing this, but be aware you might need to do ventilation. You might need to replace mechanicals. Yeah, question.
We are home inspectors. We're not house counselors. And so will we be stepping over our bounds if we start prioritizing things? In my mind, I'm just going to report the conditions.
Yeah.
And I may give some advice, but I don't know. Right now, they're only using one bathroom. They might have other people come live in the house, you know.
Mm-hmm. You asked the key question right there. Like this is outside of my lane, right? As a home inspector. Yeah, a lot of it is. And I agree with you. Like, I think the conversations that I'm having with you are ones that I have with my clients, but I don't think that you need to be having this kind of level of detail conversation with every home inspection, with every home buyer. That would be way outside of your scope. I'm hoping this class can do is help you understand that there's so much more to a house than what's on your typical checklist that really impact a homeowner's quality of life and pocketbook and health and safety. That if we're aware and educated that these things are existing, that hopefully if there's anything blaring at you, you can at least put a mention of in your report, I'm seeing this, there's no attic access, it may not be insulated, have it inspected. You can bring it up to the homeowner and help them be aware of it. I'm not saying it's your job to diagnose everything and explain all these things. I'm hoping that as home inspectors, we can go out there and recognize, wow, this thermal boundary is non-existent. They might have some comfort issues here. And at least, maybe mention it or talk to them about it. Hey, have you ever lived in a house like this before? Because this could be different from what you're used to, and it might not feel as comfortable. Because I think there's a lot of people that I talk to that are frustrated that things like this were never talked to them at any point in time in the buying process or living there. You get all these specialized fields that look at one part of the house. So if a homeowner thinks they have an issue in this part, they're now the doctor, the homeowner is, and they have no clue. They call that specialist. The specialist comes out, looks at that piece, does their thing, and they leave. And now they're creating potentially more problems. So if we leave it up to the homeowner, they're screwed. If we leave it up to the contractor, they're screwed. As a home inspector, we're looking at all these pieces and evaluating it, and they're trusting us. So, there's a line there, and I don't know what that line is. I leave that up to you guys to figure out how far you go with it. But I think just understanding that the house is a system is beneficial for our business and for our clients. Yeah. Yeah, question.
Question or
Or
response?
comment, yep.
I think it's a little bit of a gap in the marketplace between what we do and what Tessa does. I've been working on some personal research of, trying to get a better grasp of what a home inspection is versus what the public thinks and expects out of a home inspection.
Yes.
I mean, I just love now anymore when a realtor says, "Oh, follow your inspector around. He'll tell you everything you need to know about the house."
Oof.
I've started turning to realtors and say, "Do you really want me to tell them everything about this house on there? Because you'll never sell a house on there." But I think the expectation from the public is growing. Plus we have, we're moving into these generations now. I blame it, I say it started at .com. Kids came out of hanging out in the garage with their father and grandfather. We've got people that don't know a thing, where all of us grew up tooling around with something. So we have some basic grasp. But, I ask people when they get there, part of the driveway spiel, what's your what's your handiness level on a scale of 0 to 10? 7 doesn't count. Zero is I call somebody to change a light bulb. 10, I'll build a house, but my wife won't let me. You know, on there. So
Yeah.
I think it's a change coming in our industry on that. So during all this, I'm thinking is like, how can I fill that gap? Can we offer an additional product, you know, of a consultation, you know, that is going a little bit deeper into that, but it's an additional product. So there is a separation between the two on there where we are giving them more of a picture. Hey, here are the additional things you need to consider. I don't know.
Thanks, Richard. That's very helpful. And you know, I just want to add to that. I think what I've seen in the industry too, just in the last few years, is what you're talking about, kind of offering these services to clients who want these things, but they're an add-on. So for me, I've seen it like in terms of air quality, like homeowners are freaked out about, you know, mold, there are contaminants in their house that are making them sick, especially after COVID, right? More people spending time inside. And so I've seen like the industry adapt, and now a lot of home inspection companies or whatever are, you know, adding like radon testing or mold testing or these other additional things that are kind of outside of like what's required or the scope, but trying to kind of touch on these concerns that everybody has. So yeah, I don't know what it's going to look like, you know, 5, 10 years from now, but I think this is the direction it's heading. People expect their house to be comfortable and safe and durable. And when it's not, you know, whose job is it to tell them or educate them or to fix it? I don't know. We need more building scientists out there, people that think about the house as a system. And I think we're in the best position to do that because, you know, we're already looking at the entire house and evaluating all the systems and talking to the homeowner at that point when they're about, you know, to make a purchase. Yep, yep, good points. Okay, good conversation here. So just the last slide on this house, wrapping up here before we move to the next one. Just the key lessons for me are just, you know, again, these piecemeal upgrades that a lot of people think that they're improving things actually just sometimes create more issues. And throwing more heat at a problem doesn't always fix it. And I always, you know, that analogy I made with the car and the windows down, you know, do you put in a bigger heater or do you roll the windows up first? That's always my approach kind of on a house. It's like, if we've got a house that's very leaky and has no insulation, are we going to put in a bigger boiler and more electric baseboard heat? Or are we going to try and make this envelope more energy efficient and perform better? So that's where I would start, is let's make the building envelope more efficient. Because when you go to replace that boiler, it's going to change the heat load calcs on it too. If you have a house that was really, really leaky before and not insulated, and you know, do some air sealing insulation, you're going to change the size heating or cooling system that you need for that house too.
Tessa,
Yes, question, Sean.
piggybacking on what you just said,
Yeah.
changing the boiler layout, adding heat to that room or whatever,
Yeah.
that's going to impact the rest of the whole entire house.
For sure.
Where those BTUs get placed and all that too.
For
So
sure.
that can have a big impact.
Yes, good point, Sean. Yep. And once you've got that envelope more airtight and better sealed and insulated, you're gonna, you know, reduce your utility bills, but you also could impact, you know, again, the air exchanges in the house and how much moisture accumulates and contaminants and everything like that. So you need to be thinking about ventilation with the building envelope and air sealing. They go hand in hand. And then also recheck the mechanicals if you've got, you know, natural draft systems that are susceptible to pressure changes. And then, again, planning these improvements with somebody as a system, or at least making them aware that if you change one thing, you can impact another. At the very least, as a, you know, as a home inspector, you're not going to be planning these improvements, but you could at least let them know, hey, if you do some of this air sealing insulation work in the house, you might need to add some more ventilation too. So you should be thinking about that. And you know, it might impact how your water heater drafts too, and you might want to get that retested, make sure it's still safe after you do all this air sealing. So, okay. Good discussion, good thoughts on this one. Let's move on. We've got case study number 3. So this was a house in Indiana, actually. This was a homeowner that reached out to me. This house was built in 2002. And the issue was he had a soft wall that his office was in the room, this room actually right up here. He had an office. He worked from home up here, and he would sit at his desk and lean his feet against the wall. And one day his feet punched through the drywall, and so he freaked out and he kind of looked at it, opened it up, and it was all moldy, and had no idea what was going on. So how much moisture's in the wall? How bad is it? Is this just the tip of the iceberg? So the goal was to try and figure out, what's going on here? How did this happen and how do we fix it? Okay, here's a bird's eye view of the house. You know what? Houses that have frost on them and a morning inspection are like, oh, it's too bright in this room. You can't see it. It's hard to see. There's a little bit of frost on this north slope above the garage, and you can see melt patterns in it. Frost is like nature's IR camera, because you can see exactly where there's like heat loss happening. Here's another shot. Maybe you can see a little bit better in that one. I don't know. Maybe the people online hopefully can see that pretty good, but there's patches where there's melt on that frost right at the where the slant ceiling is at the top and the bottom of that slant where it transitions to flat knee wall and then upper peak flat. So there's a lot of air leakage happening there. Here's the back of the house, just kind of getting oriented. So you can kind of picture what's going on here. Yep, here's that upper room above the garage that he was using for his office. And here's the mold remediation that went underway in some of these spaces. They have pretty horrifying what's going on here. Pretty bad. Yeah. Pretty nasty. So he went through this mold remediation process, and then the wall was soft again after this mold remediation process. So they opened up the wall, cleaned it all out, and then put it back together. They didn't obviously fix the solution or fix the source of the problem though, right? Okay, so here's just some more pictures of everything. Now, some of these, stains on the wall sheathing get worse and more concentrated right underneath that window, under the corner of the window. So, I mean, I'm just thinking like some of this water intrusion could be from leaks around these penetrations in the windows. But that doesn't explain all the mold everywhere else where we don't have windows. Here's some more pictures. Okay, so he actually supplied me with the inspection report he had. So I was really curious to kind of look through that and see, what the home inspection noted. And I just wanted to highlight this is kind of their summary page, and major repairs and safety hazards and general repairs were listed here. So I'll just touch on that. They said the brick windowsills are installed with minimal fall, and there are deteriorating mortar joints. See the photos? The tops of the front porch posts are not finished. The hardboard siding has no relief to the roof at the joining walls. Due to these improper installations, there are deteriorating boards and wood trim boards. Okay. Also, maintenance and improvements. They have windows and door steel lintels are rusting. So those are a couple things they highlighted here. And here's some of the pictures that relate to those things they're talking about. So in picture 9, top center, the siding is tight to the shingles there, and there's some deterioration happening. Looks like it's fiber cement there. And we're missing kickout flashing in 11. You can see the wood trim board is looking like it's a little bit soft, probably deteriorated. We've got 13 rusting lintels. So here were the action items from this report. They were from the plumbing section, the electrical section, and then that was it. So this report highlighted that the second floor furnace gas pipe condensation drip leg appears to be missing. Suggest having further evaluated by a licensed contractor. Repair is needed. That was the number one action item. Also, there's no visible evidence that the flexible steel gas piping in the second floor furnace is bonded to the electrical ground. It's a safety concern, have it evaluated and repaired. And then they also said, be advised, height location of the kitchen countertop outlets may not meet current code requirements. So if you're a homeowner and you don't know anything about houses, that's what you're primarily concerned about. Yeah, that was their action items. Okay, consideration items. Now, these are about more of the siding and window things. So consider these things. There are areas of deteriorated exterior siding, suggest having further evaluated by a licensed contractor and repair as needed. The steel lintels over the windows and door openings should be painted with a rust inhibiting paint to prevent rusting, which can contribute to damaged bricks. They also said there were minor exterior brick cracks visible at the rear screen porch. Repair is needed. Okay, they talk about replacing window screens that are missing, verifying basement windows meet current egress standards. And then at the bottom for trim, they say there's minor deteriorated exterior trim at various areas of home, suggest having further evaluated by a licensed contractor and repair replace as needed. Okay. They also talk about furnace needing an overflow pan and adding screens to the furnace exterior piping is needed. And then verifying that both the furnace humidifiers are working properly with the homeowner. So here's pictures of some of those things that they included. Pointing out the siding's tight to the shingles and it's deteriorating and have it evaluated further and repaired as needed. The rusting lintels, and then the bottom, we've got pictures of the cracks in the brick. Okay, and then on this next slide, just again, more pictures of kind of deteriorated trim and siding and trim around porch posts. Also, key at the bottom there, we've got the, the roof wall intersection with no kick-out flashing and rotted trim board there. Here's pictures of the back porch with the cracks they called out in the wall and then where the slab meets the house. Okay. So, sorry guys. Okay, this is a short one because I did not go out to this house. I didn't do an investigation. I talked to him about what I thought could be going on in this house. Now, anyone want to take a stab at what they think might be causing all of this mold and moisture in the wall? All that mold behind the sheetrock that made it soft. Now, there's definitely places where we could be getting bulk water, exterior water leaking in, right? That's, all these pictures of soft trim, missing kick-out flashing, cracks. They mentioned the deteriorated mortar and the, improper pitch of the bricks of the windowsills. So it could be that bulk water intrusion is contributing to some of this. But what about the rest of, these areas that had the mold and the moisture? Like what could be causing that? Does anybody have any theories or takes on that? Yeah, Sean.
Maybe the humidifier was set too high, adding too much water. And then there was poor air sealing and all that stuff in the vaulted cathedral ceiling assembly in that room.
Yes, that's very possible because we know there's a whole house humidifier. And so if homeowners are not cautious with that, we can be pumping a lot of moisture into these spaces, right? And then this, in Indiana, I believe they do have, in some of these pictures, I noticed that some of the walls behind the sheetrock had poly vapor barrier and then fiberglass. Some of them had a poly vapor barrier and then paper backed fiberglass as well. And so I asked him about that. And he said, well, yeah, I'm not really sure. I think there's poly in the house, and maybe when we did the mold remediation, we didn't put it back in some of those spaces. So there may or may not be poly vapor barrier on all of it, but my guess is there's probably there's sheetrock, poly vapor barrier, fiberglass on the original house. Do you guys remember on the slide talking about vapor diffusion and how vapor can diffuse through porous materials? Okay, so if the wall assembly, I'm assuming, is this brick veneer, we might have some sort of weather resistive barrier, WRB like Tyvek or something. on the exterior wall sheathing, possibly. Now, Tyvek is not a vapor barrier. It will allow vapor to move through it. It has, a lower perm rating. So bulk water will run down it, but vapor can drive through it. Okay, so we've got brick, weather resistant barrier, most likely, wood wall sheathing. This is a newer house, so it's probably OSB. And then we've got fiberglass, bats, poly vapor barrier, and sheetrock. What happens when these brick walls get saturated with rain and the sun comes out? Remember that slide that showed the vapor pressure profile and where that moisture wants to go? Yeah, it's drying both out and in, right? So that, in theory, that moisture the brick is holding can now dry to the inside through the weather resistant barrier, which allows vapor permeance, through the OSB, through the fiberglass, and then potentially, can get to the drywall if we don't have a vapor barrier, or if we do have a vapor barrier with holes, which they all do, can still get to the drywall. And if we're cooling, if it's a cooling season, or we're running the AC, it's cold inside, hot outside. We've got a cold surface on the inside, the sheetrock. We've got hot, humid air coming through. We're going to get condensation on the back of that cold sheetrock, right? So all that moisture is condensing on the back of that sheetrock. And over time, we'll just build up and make it softer and softer, or moldier and moldier. It's possible, right? It's possible. It'd be one explanation for maybe why we've got all this mold happening everywhere where we don't have potentially active bulk water leaking in. Okay, I see lots of hands going up. First, I'll answer, yes, person in the red vest.
So the sprinkler system, irrigation system, I guess, I'm assuming that, okay.
Yes. Yeah.
Those things spray water all over the place, put that water right on that brick,
Yes.
but it hasn't rained. Oh, it's raining.
Yeah.
It's raining
Every
on the
day at
house.
9 o'clock. Yeah.
Yep.
Yeah. Yep. That's a good point. That could be wetting the walls as well. His office was on the second story. And so there's definitely potential moisture issues on the first floor, and all these places we're seeing the cracks in the sprinkler system. But we've also got moisture issues on the second floor too, where we don't have a sprinkler system watering the wall.
Was it a garage underneath of?
Yes, there's a garage underneath his office.
Okay.
Yep.
Ought to be opening those walls too.
Yep. Could be. Yes.
Was there any discussion of ventilation and insulation in the attic?
So that space, the room with his office was finished slant walls with a tiny little peak attic. So, I'm assuming it's the fiberglass bats in all the rafters up there too. He hadn't done any sort of major upgrade to what the house was originally built as. So I don't believe that there was any spray foam or anything up there. I think it was the original fiberglass bats there. But no, we didn't talk about going up in the attic or having him look at that or anything. So that's another good point. Yes. Question. Comment.
Where's the rain face on this property?
So it looked like on the ridge, all the passive vents were lined up. There was no ridge vent. There was about 8 passive vents along the roof line, but they were all on one side, the back side of the roof. And that ridge board may be blocking off potential ventilation from the front of the house.
Sure.
Because that ceiling looked like it's elevated all the way up to the ridge, if you look at it from inside the house. So that air's kind of getting trapped on the front. And I don't know if there's any soffit ventilation under there. I don't see in the front if there's
Yeah, it's hard. There's not a whole lot of places for intakes.
there's no gable vent, and I don't know if there's soffit ventilation.
Yeah.
So that would be
Yeah.
that should be added. There's
Yeah.
a little bit of an overhang, so you should be able to get some soffit ventilation in there.
Because of the dormers on the front, or the gables, I mean, you only have a few little sections where you can do some intake for the front part of the house there. And I'm not sure what the attic looks like in this house. If we've got a larger upper flat attic where you can physically crawl up there, or if you've got some slant ceilings that, you've got a ceiling and then a roof deck pretty close to it, with Any ventilation?
Inches there above the insulation.
Could be a couple inches above the insulation for ventilation, but
He's basically living in the attic.
we don't know. He's basically living in the attic. Yeah. Yeah. So this one's a tricky one. Any other, anyone want to add any other thoughts on this one?
Yeah.
So I think there could be multiple things going
it?
on. I think there could be bulk water intrusion from the things that we saw on the exterior, and I think there could be maybe some vapor diffusion happening in this house as well. There could be issues with, inadequate attic ventilation into, although that doesn't necessarily explain all the issues with the mold in the walls too. So this was an interesting one, and I talked to him about these, potential causes and things that could be happening in this house. And my recommendation was that he probably needed to conduct a further investigation, determine, what was happening here. And again, first starting with, let's stop the water from getting in where we know it's getting in. So prioritize exterior water intrusion issues. And then let's see if we can address the vapor drive that's happening through this wall, if that's what's going on after further investigation. Yeah, Sean.
Did the veneer assembly have like weep holes?
It did not, because on the pictures I could see in that inspection report, like right back here on the porch where the wall meets the patio, there's no gap. So it's another good point. Yeah, yep, and we talked about that too, just water can't drain out in these areas. Yep, yep. So there could be a lot going on with the exterior here. And what's interesting is I believe he told me too that, I'm gonna go back to this original front picture. All of this mold and stuff, the soft sheetrock was showing up mainly in this kind of this space, the upper level brick areas on that front gable on the right that has brick on it was a room that had mold remediation, and then his office above the garage with the brick had mold remediation. But they hadn't found it or were not doing the other areas that were just the wood, the fiber cement. It was just the brick. So again, it kind of makes me wonder, is it vapor drive happening through the brick? And that's what's causing it? The brick's holding the moisture, it's like a sponge, and then the sun is pushing it in, the AC is pulling it in, and it's causing issues in those areas. It's tough to know. So I recommended he talk to Mark Parley, who specializes in doing intrusive investigative searches for causes of moisture in houses like this. So I need to follow up with Mark and see if he went out there and worked with this guy. I don't know at this point, but I'd be curious to know. So I think this is just a situation where it's we've got a newer construction with all these building materials that are less resistant to moisture. We've got more materials that are reduce the ability for drying. We've got complex airflows happening through these wall and roof assemblies, and we've got improperly installed and maintained exterior cladding. So all of these factors are kind of creating the perfect storm here with all this moisture that's happening in the house and the mold and the rot. Kind of rough for this guy. Luckily, he had a big budget though, so I think he could handle what was going to be coming his way, hopefully. Okay. And then here is the last case study that I have. I think, how are we doing on time? We got perfect. Okay. 15 minutes. That's just enough time to get through this one. Okay. So here's another house. It was in Minnesota, built in the 1920s. They had water dripping in through the ceiling in the winter time specifically. Now this is key. If people are having moisture issues, I always like to know, well, when are you seeing it? Is it after a heavy rain? Well, that's probably bulk water intrusion. Or is it like in the middle of winter? Okay, that's probably something different. So they wanted to find out what the root cause was and the recommended solutions. So let's start by doing a visual inspection on the outside. What do you think about trying to get a consistent and continuous thermal and pressure boundary in this house based on the design? It's complex, keyword. That's all we got to know. It's complex. So the chances of having a consistent, continuous pressure boundary, air boundary is very difficult in a house like this. But also, okay, this is when I was inspecting going up on roofs. We've got some areas that potentially are, highly suspicious. Okay, yes, I did poke a hole, but okay, making a point. We've also got plumbing vents with caps that are split, and we've got, all this flashing around the chimney that has gaps and hasn't been sealed very well and has been added at a later point. Okay, so places on the roof that could be leaking water in. Number one, is it bulk water intrusion? At this point, don't really know for sure. It could be adding to some issues. Let's look at the inside. So we've got some slant areas because of those dormers in the roof line. Here's a side attic where they were using it to store items. Now we can see in this picture here, they had added closed-cell spray foam. They were trying to make their house more energy efficient, more comfortable, so they did closed-cell spray foam. However, if you look in the upper left corner, that's the original like bat. And if I go back one, see that corner up there too? They did spray foam where it was like convenient, but they missed some spots that were visible. Okay. We also have, it's hard to see in these because of the brightness in this room, but I'll try and highlight it. There's just, where's my, oops. Let me go back, sorry. Try this again. There's just water staining down a lot of these slopes and slants in this house. Here's another example. Kind of there's a seam, there's a crack. Oops, there's a crack in the sheetrock and there's more staining. So just looking at all the different stains in this house. And then using an infrared camera, this is without a blower door, so without depressurizing. Getting a look, and there's definitely areas that I believe are probably still actively wet at the time. This is what it looks like to me. And then you can see just the kind of inconsistencies in the thermal boundary where we've got the slants, we've got lots of thermal bridging happening, areas that are cooler, same thing here. They had ice dams, and so one of the reasons they did spray foam is because they were like, oh, we'll stop the ice dams by adding the spray foam. So here's some more cold areas, some more cold spots, some more cold spots. And I turned on, let's see, I don't think they had any exhaust fans, but this is just, again, there's areas that spray foam you can see are not consistent, where we've got cold spots here. Okay, so we have an inconsistent thermal and pressure boundary in this house, clearly. Let's look at the mechanical systems. We've got a new sealed combustion boiler for this house, brand new. They left the water heater, so now we've got an orphaned natural draft water heater venting into the chimney all by itself. We also have lots of condensation on the windows, and it's not that cold outside. Bathroom, missing something. Yep, missing a bath fan. Additional information. They also had installed windows in the last few years, so newer windows. There was no exhaust ventilation in any of the bathrooms or the kitchen, which is typical of a house that's 1920s. And then homeowners stated that the water staining appeared during cold weather, so not noticeable staining after heavy rains since the closed-cell spray foam was installed. Okay, so that's helpful too. Now, I was curious, after I looked at this spray foam application and I saw all these areas where I could literally reach up and touch the roof deck, in these corners and slants, I was like, what did the spray foam company do? And they're like, oh, well, they sprayed all the accessible areas. And I was like, oh, okay, well, do you have like any information that they gave you about what they did, their scope of work? Oops. I'll see if I'll read this to you guys. It says, the notes for this scope of work: foam insulation in all exterior walls of upstairs space and ceiling. I was like, did you guys remove any lath and plaster or sheetrock or anything? They're like, no. It's like, how did they get insulation in all the exterior walls of the upstairs space and ceiling? Don't know. Okay. But they did put in parentheses, none in area below window in master bedroom. Oh, well, that's very specific and helpful. Okay, thank you. Also, putting foam in ceiling of living room, roof space on front side of house. Crawl spaces included. I don't know what they mean by crawl spaces. Are they talking about side attics? I don't know, but I want to go back and just show you the front of this house. I think what they're talking about, the floor of that attic space, is actually this, I think they're talking, whoops, I think they're talking about this, like they made an access to that. But again, I mean, it's very unclear to me what they actually did. And from the language that they wrote down, it's clear I don't think they know what they did either. So putting the pieces together, that does not give me confidence that there is a consistent thermal and pressure boundary throughout the entire lid or knee walls of this house. They didn't remove any sheetrock or any lath and plaster, and they only sprayed some of the areas that were accessible at best. Okay, so this house was made more airtight, but not consistently airtight. Okay, and we still have the mechanical systems. So additional information, we went through that. Okay, so here's the building science summarized. They tightened up the house through this air sealing, the accessible spaces with closed cell spray foam, and the installation of the newer windows. So they reduced the air changes also by replacing this older sealed combustion boiler with, or by replacing the old boiler with a newer sealed combustion boiler as well. We talked about reducing the air changes when you have a sealed combustion appliance. And they also don't have any mechanical ventilation, no kitchen or bath fans. And the key thing here is that we've got a moisture load in this house that now we don't have the air exchange with the old boiler, and we don't have all the leaks of the breathing through the building envelope too. Now we've concentrated where the leaks are to the little tiny spaces that they didn't air seal. So in theory, they made the house more airtight and better insulated in some areas, but we still have some spaces that are leaking. So if you ever like take a garden hose and you've got water coming out the end and you take your thumb and you cover half of it, you still have the same like volume of water coming through. It's just at a higher velocity, right? Think about the lid of this house. We've like sealed up maybe half of it, but we still have half the leaks.
I forgot
So we've got more moisture in the house
last night.
and we still have some of these leaks. I think we've
Last
concentrated
night I forgot that I had
the
an
moisture and the
8-hour
air leakage happening into the
online
attic and wall
Zoom
spaces in these areas that didn't get sealed. So the moisture used to kind of be leaking everywhere
seminar.
evenly and could probably be absorbed a little bit better by the fiberglass or the cellulose, whatever they had up there. Now we took that away, put in a material that doesn't absorb
I had
moisture,
to
and
attend
we've
today,
isolated
get
where
my
we're throwing the
ongoing
moisture.
education credits for
It's
ASHE.
going to show up faster that way, right? So the unintended consequences of doing these incremental improvements, they've created potentially now a backdrafting water heater because they've made the house more airtight, and they still have, and they, orphaned their water heater. They've also got excess humidity that could lead to mold and moisture issues. We saw all the condensation on the windows. And we've created these new potential durability issues and performance issues. They still had ice dams. And now, like I said before, we're injecting this moisture into specific areas where it's highly concentrated. So we're going to be potentially rotting out roof deck and walls faster in these areas. So these attic air leaks allow moisture to accumulate in these voids in the insulation in the cold attic spaces, which can lead to condensation and frost. So, summary, the unintended consequences of these incremental improvements led to water dripping in from the ceiling when it was cold outside after they'd had, long spells of that moisture building up, condensing, building up the frost, and then melting when it would get warmer and dripping back down, which is going to lead to potential rot and building durability issues, increase in potential mold and moisture problems, and combustion safety issues. So, holistic solution. At this point, to try and make a consistent thermal and pressure boundary in this house, it's going to be tough, right? Because of the complex roof line and all the inaccessible areas and the slants. it's really, really tough. So for me, the most cost-effective thing and the lowest hanging fruit is we have to reduce the humidity levels in this house. Remember the psychrometric chart? You can either increase the temperature or reduce the humidity, try and reduce the potential for condensation. So let's try and reduce the humidity. So, okay, what does that look like? Well, we don't have any sort of ventilation in this house. So let's add some ventilation. Let's make sure you use it when you're cooking, when you're showering, all of these things. Also, when we add more point source ventilation, we need to think about the impact on the water heater, right? So probably replacing that water heater with a power vent or direct vent or electric unit. And then we do these things. If we still have problems with condensation, then we do need to address the building envelope. And we do need to try to get a consistent pressure boundary, air boundary up there. So working with a really good skilled contractor who does insulation or building envelope improvements would be key to trying to figure out a solution to this one. Okay, the key lessons, hammering this one home. So if we've got an inconsistent thermal and pressure boundary with air leakage and high humidity, we're going to create moisture issues. Combustion safety and improved ventilation strategies should be addressed, ideally, before they tighten the building envelope. And also, this poor spray foam application and scope of work just moved the problem, concentrated it to certain locations, and they still had ice dams. So, okay, wrapping up here, we've got 5 minutes. This is perfect. Just wanted to review high level, this big picture. Again, the building science principles are key. And if you understand these, you can think through each house individually. Just apply the same physics concepts to each unique situation, and you can think it through. So we've got heat goes from warm to cold, more to less. Air goes from high to low pressure. Moisture goes from wet to dry, more to less. We want to control these things so we can have success. And we can we can control it when it comes to the building and the structure, mechanicals, environment, but, occupants, they're the wild card a lot of times. And, whether or not a house performs well is going to depend on all these different variables, the materials, what the house is made of, how it was built, how they've updated it and changed it, where the house is located, the design, the climate, the mechanical systems that are installed, and then again, of course, occupant behavior and expectations. So we've kind of touched on this, but if we think about the house as a system, hopefully, I think it can help you reduce any potential liability if you're not commenting on some of these things that could be big issues for a client. At least you're aware of them and hopefully having that conversation with the client, building trust, improving your outcome. So it's about thinking in systems, not parts, looking beyond the obvious and understanding what those symptoms are and the mechanisms that go into creating them and thinking about the root cause of that and what is the risk to the homeowner, to the house, and then helping them understand what could be done to fix it. So talking to your clients, again, I think is really, really important, understanding what matters to them going into it so you're not missing anything that they are really concerned about. Okay, so this is the last slide here. Hopefully you think about the house as a system and hopefully you can start applying some of this kind of systems thinking when you're doing your inspection. So you're not just checking the boxes, you're thinking about the big picture. All right, and then I think I put a QR code that has my contact information on it. You can scan it and I think it just gets put into your phone, but also my email address is down there on my website too, housecoachtessa@gmail and yourhousecoach.com. And Ruben, the owner of Structure Tech, we do a podcast. We've been doing it since 2019. And so if you've got time and you're driving the car and you want to listen to a home inspector podcast, that's one you can check out. So anyways, that's okay. Oh, I'll go back. Sorry. That's it. That's the last slide.